Welcome to this project, which is all about helping you to become an advanced blockchain developer and build something meaningful. So in this lecture, I am going to give you all around introduction to this project. But before that, let me introduce myself. So, hello, my name is Rohit Sonone and I am a blockchain developer and consultant, and I have 7 years of experience in software development and consulting. And past from several months, I am mostly involved with the blockchain consulting and programming. I have the good knowledge of cryptocurrencies, Ethereum standards, front-end technologies like Angular and React. I have also a good knowledge of the mobile programming language like Android. So I can better tell you about the blockchain things because of the variety of knowledge that I have in other technologies also. So we will see that things in this project, how we are going to deploy various things in a blockchain. So before we start with this project, within the next lecture, I just want to make sure that you are aware of the key things that will required for this project. I have structured this project in such a way that everyone can understand and they feel comfortable while watching these video tutorials. So by the end of this project development, you will be very familiar with the blockchain concepts and the basics of the blockchains and the things that I'm going to tell you in this project. So those you can be very familiar at the end. You will understand the workflows and ecosystems of the blockchain in this course, right? And also in this project, if possible, we are going to write down the smart contracts for the some ERC standards, and like ERC20 and ERC721. Maybe there are lots of ERC standards, but we will take any two ERC contracts, and I will show you how they actually works. So what is actually fungible and non-fungible things so in this project. And if possible also, I will try to build a front end for the those contract also. We also look into the Ganache thing, that is the local test network for our projects, what is the remix and all that stuff. Okay, so let me talk about this project. So this project is all about fungible and non-fungible tokens. What is meant by fungible and non-fungible tokens? What are the different types of token standards, and when and at which time we should use different types of token standards? So that we are going to see in this project. So let me show you the ERC standards first. So ERC token standard, if you go to the Google and if you find that ERC20 token standards, and if you go to this page of ERC20, so what is ERC20? So ERC20 is nothing but a smart contract on the Ethereum blockchain for implementing tokens, right? As the definition here they have given. Okay, but what is ERC? So ERC stands for an Ethereum request for comment, right? And 20 is the number that was assigned to this request, right? So if you're a beginner in the blockchain, you can find different ERC standards contract on the internet, and you get confused. So which standard to be used and what is the difference between them? So that is the thing that we are going to see in this project. Okay, so for more information you can go to this token standards GitHub page also. So here you'll find different things on this page also, right? So we will see all that stuff in the next lecture. For this introduction lecture, this is it. Thanks for watching. So hello, welcome to this lecture. So in this lecture we are going to see the different types of ERC token standards, how and when to use that. Okay, what are the most popular ERC20 or ERC token standards? So in this lecture or in this series, we are going to cover these most popular ERC token standard, that is ERC20. After that, ERC721, ERC223, ERC875, and ERC1155. So these are the most popular ERC token standards right now, right? If you go to the google.com and if you go to their main website of ERC token standard GitHub page, so here you will find different types of ERC and EIPs. Okay, so this is the token standard for ERC20, right? ERC20 actually published in late 2015, but this is actually implemented in 2017. So if you go to the many cryptocurrency websites, you will find that their token is based on this ERC20 standard, because this is the most popular token standard on which many crypto exchanges and cryptocurrencies are based upon. So this is the very famous standards, right? But in this project we are actually going to see popular ERCs, right? So also let me go to this EIP thing. So EIP is nothing but you can say non-approved ERC token standards, right? So if you see here is the list of EIPs. So these are the improvements that actually suggested by the authors and the developers for these protocols, right? But these are called the EIPs because these are not approved or these are not standardized. These are just the suggestions and the things that the developers actually suggested in that particular EIP protocol or standard, right? So when the Ethereum community get a consensus on a particular standard, then that EIP becomes an token standards and that people can use. So here you find many types of EIPs here, and from these EIPs just you can see that in this last September month a new token standard has been issued, that is ERC 1400 also, right? So if we find so many token standards here, we can find that different token standards like ERC20, right, to ERC223, that is EIP here, ERC EIP 721. After that lots of EIPs are here. Okay, so why actually these EIPs are here and what is the use of this, right? So as we say, as I said, that many token exchanges and many cryptocurrencies is based on this ERC20 token standard, right? But there are lots of flaws present in this ERC20, and that is the problem with the basic ERC20 token, right? If we go to this page, this is the official page for ERC20 token standard. So this is the first token standard that is published by the Ethereum, right? So but as we see in any software programming language or in any standards of in programming, there are always be an improvement in the language and the code, right? So in the similar way, people found many flaws in these ERC20 token standards, and they suggested the improvement for this ERC20 or ERC token standards, and that's why they become like ERC223, ERC721 and such things like that, right? So here you will find a full description about ERC20 token standards, and this we are going to see in the next lecture, what is ERC20 token standards and what is the contract and other stuff that we are going to see in this ERC20 token standards. So we will meet in the next lecture. Thanks for watching. Hello everyone. So in this lecture we are going to see what is a blockchain, and in this session we are going to cover the basics of a blockchain, so you can understanding the foundation of a blockchain, so you will understand the future coding and the syntax that we are going to write down in this course. So let me start with the what is a blockchain. So if you're I think if you are doing this course, you must probably know what is a blockchain is all about, but let me explain a little bit amount of data for this. So what is a blockchain? So blockchain is a type of a distributed ledger for maintaining a permanent and a tamper-proof record of transactional data. A blockchain functions as a decentralized database that is managed by computers belonging to peer-to-peer network. So what is actually this definition is all about? Okay, if we are going to see this slide, here you can see different types of networks here. So this is centralized, decentralized and distributed networks. Okay, these are some new networks that are present right now in the world. So what is the difference between the centralized, decentralized and distributed system? So in centralized system, all you know is that every node or every computer in that network is connected to some centralized system or some centralized server. So that's why it is called a centralized system. So in today's world, many of the systems that we are using over the internet are centralized system. Means that there is some server like for like some Google server at some central location, and we are accessing that central database of a Google from our computer. So that is a centralized system. Then what is meant by decentralized system, and why it is needed to make a network that is decentralized? So the main problem with the centralized system is that if the server goes down, okay, the central point where we are all connected, if that goes down, we cannot communicate with each other, right? If this central system goes down, then this node cannot communicate with this node, right? Because the central system is down and there is no medium through which I can communicate. So to eradicate this problem, the computer engineer come up with this decentralized system. So in decentralized system, as you can see here, there are different types of nodes here, right? And there are some little networks you can see here. Okay, and those little networks are connected to their some centralized smaller server, you can say. Okay, but the decentralized system has also a problem of the failure for particular nodes. Like if this node wants to communicate with this node, okay, but this node goes down, then this node cannot communicate with this node. So this is the problem with the decentralized system. But advantage is only that all the network does not goes down, okay, if there is a failure of some node in the decentralized system. Okay, that is the benefit that we get in the decentralized system. So to eradicate this problem also, the network engineer comes up with the distributed system. So this in the distributed system, as you can see that everything is connected to everything, means every node is connected to every node, and there are multiple routes by which they can communicate with each other, right? So if, for example, if this node wants to talk with this node, okay, and for example if this node goes down, still this node can communicate through this node with this, right? So in distributed system, the network never goes down, okay, and every node can communicate with each other, and there will be no effect of a particular node if goes down, so network still will be alive. So that is the benefit of the distributed system that we get in distributed network. So what is a blockchain is all about? So blockchain is a decentralized and a distributed at the same time. Okay, so it is a decentralized, so there is no particular central server present in the blockchain, and it is distributed also, means every node is connected to each and every node through some network over the internet. So if a particular PC goes down or a particular node goes down, still there will be no problem in a blockchain, okay, to get a data or to send a data. Right, so this is the main difference between centralized and the blockchain systems, you can say. So as we can see in the next slide also, here you can see the same image with the computers, and the network is a distributed system, right? So here you can see it's a shared public ledger, okay, of transaction. So this is the shared system, it's a public, so anyone can see a data on a blockchain, okay, and a ledger of transactions. So each and every node has updated transactions and ledger, right? So if I download the blockchain node into my computer, I can also see the transactions of a particular person, because blockchain is a public thing, right? So anyone can inspect the transactions. So there is no hidden type of things in a blockchain. So it is all transparent and no single entity controls. So the best beauty of a blockchain is that no a particular company and there is no particular owner for a blockchain system. Means that there is no company, there is nothing that owns this system, okay, and that is the beauty of the blockchain, that no one owns the system and still it goes on, right? So we will look a little bit about history of a blockchain. So where is it come from, and who developed this, and how it came into the existence. So in 2007, a person named Satoshi Nakamoto begins the working on this concept called Bitcoin, right? In 2008, he published a white paper on a Bitcoin, and after that he started working on this concept called Bitcoin. So as many of you know the Bitcoin and what is a Bitcoin is all about. So Bitcoin is just a cryptocurrency that people trade for fiat currency, okay, that is just a virtual currency, right? In 2009 there is a first transaction that is happened in the Bitcoin, and after that the Bitcoin journey started from year to year. And as you many of you know, in 2017 Bitcoin price is like about $11,000 US dollars. So after that the people got attention about this Bitcoin, and they find out what is the technology behind this, because Bitcoin no company owns the Bitcoin, right? And no person owns the Bitcoin company, right? It is an automated system. So people go to that particular protocol of the Bitcoin, they play that particular game of a Bitcoin, and they get the Bitcoins, and after that they trade that system. And people were amazed to see this system, that no person is involved in this system, only end users are present, but in the system no human interference is there, right? So many of the companies and developers get mesmerized by this concept, and they thought that okay, so this can be possible if we get this technology of a Bitcoin. So they researched about this technology of a Bitcoin, and they found out this the underlying technology of a Bitcoin is a blockchain. So they after that they think that, okay, so blockchain is the foundation of this Bitcoin, so we can also use this foundation for other problems that are present, and those are present right now in the world, and we can solve this problem by using this blockchain technology. So many of the developers adapted this blockchain technology. They researched for this thing, and they found that this technology is amazing. So from last 2-3 years, you can you will find that many of the applications now are built on this blockchain technology, and in the future you will see many more applications that are going to use this technology, because this is the one of the best technology that you can have. So what are the main companies or the main people that are using this thing, and they are pushing this blockchain technology forward? So the first company is the Ethereum, or the network, you can say, that is Ethereum network. So in this course also we are going to use this Ethereum network. So Ethereum networks are blockchain networks, you can say. So Ethereum networks are used to transfer money and store the data. There are many different types of Ethereum networks present in the world right now. So these networks are formed by the nodes, or you can say computers or servers. Okay, and the Ethereum nodes, you can have multiple or many thousands of computers present, right? And each node is a machine running an Ethereum client. So if you have your machine, and if you are running this Ethereum client, then you can also be a part of this Ethereum network. So anyone can run this client on their PC, and they can be a part of this Ethereum network. So, and each node or each PC will contain a full copy of a blockchain, right? So in this course we are also going to see what is actually an Ethereum network, and how to use this Ethereum protocol to build distributed applications, right? So before that, let me tell you what is actually a blockchain versus database thing, right? Many of the people get confused about what is a blockchain actually, right? So if you imagine, blockchain is nothing but a database, right? So our front end that you see right now in the world, those are done in HTML or in HTML5, React or AngularJS. Okay, those are also those things which we can use in blockchain also, because at a front end side there is no difference, right? Only at the back end or at a database level there is a difference, right? So we will see what is the main difference between blockchain and database. So first thing is that blockchain and database are same because they save data. Okay, so only difference is that blockchain saves the data in a blocks, okay, and our regular database like in MySQL or MS SQL store the data in a particular centralized data file. Okay, that is the main difference. Okay, but otherwise there is no difference when it comes to saving data on a blockchain or on a database. After that, the flow to store data is the same, right? In a centralized application also, if you want to pull up some data, that time what you do is that you write a query on your computer and you pass that query to your application server, and then your application server query to your database, and you will get the data back from your application server, right? And the same flow is for the blockchain also, because at a blockchain your computer and your application server are present. Okay, just difference is only at this side. Here instead of database, we are you will find there is a blockchain, okay, at the back end. So whenever you want to get a data or you want to store a data, that time you do the same flow that you query for your application server, then your application server query for your blockchain database, and then your blockchain database returns the data to the application server and then to your computer. So the flow is same for your database thing, or database based application, and the blockchain based application, right? But the huge difference is about the money, because as of many of you know, in the centralized database system, or the database that you used nowadays, like MongoDB, MySQL, MSSQL, okay, those database does not cost any money, but blockchain cost you a money to save particular data on to a blockchain, right? So this is the huge difference between your blockchain and your regular database, because to store a particular data on a blockchain you need to pay a money. So this is the main difference that you will find between your regular database systems and in your blockchain systems. Okay, so what is the cost of that money and other things we will see in the next lectures. Okay, also a blockchain store a record for every change ever made to its state, right? So in a normal database, okay, whenever you have some data like users and balance, okay, in the same table you change those things at the same place, right, like their balances. But in a blockchain we save every state of the blockchain, right? If you see this slide and in this image, this is the initial state, okay, and this is the balances for this user, okay. When first transaction happened, okay, just you can see here that the bill sent $10 to Alex and Jill sent $30 to Andrew, right? So this is the first transaction. So this transaction is separately saved, okay. So this state is different and this state is different, so both these state are saved in the database, in a blockchain. After that, whatever may be the future transaction, those are also going to save in the blockchain as a separate entity. So whenever you want to check, okay, for a particular transaction a hash or a particular transaction data, you can check what is the current state of that system. So this is the beauty of a blockchain, that you will get each and every transaction, and you can check every transaction on a blockchain, right? So what is a block is all about? So in a blockchain, block is all about memory chunks that you can use to store your data and the private keys for that particular blocks, right? So those are only memory chunks, okay, that you can say blocks, okay. So if you look at this example, there is always for any blockchain network, there is always a first block called a zero block or a genesis block, okay. That is a starting point for any blockchain, okay. So that's why it is called a genesis block, and it has a configuration of a how many coins and how many things it will contain in that block, okay. So that configuration is present in that genesis block, okay. And after that, whenever there is some transaction happened on a blockchain, so that time another block is created, okay. And in that block, the previous transactions from the previous block is also saved in that new current block, and the current transaction are also saved in that block, okay. So just like that, for every transaction this process happened again and again and again and again, and all these blocks are connected to each and every one, okay, in a linear manner, right? So that is why it is a block, that is why it is called a blockchain, okay. As I told you that about the genesis block, the first block, okay, right? So we can configure it, okay. So if you want to start your own blockchain network, So that you have to first create this file called genesis.json, and in that file you have to write down some configurations, okay, and after that you can use that file to start your blockchain network. In the mainnet also, at some point someone has created this block 0 or genesis block at some point of time, you can say, okay. And you can also develop, or you can also deploy a private blockchain network using this genesis.json in your computer, okay. You does not need to go to your main network to publish your dApps or something that you want to publish every time. You does not need to go to the public server for publishing, right, because it costs also money. You can also develop your, or you can also deploy your private blockchain in your PC, and you can test and configure your dApps over there also, okay. So this is the beauty of a blockchain, okay. And as I said that the transaction for every transaction, okay, the blocks get added. So who actually mine these blocks, right? So there are some miners, okay. Who mines means they validate the blocks, right, and they validate according to the rules or the consensus of a network, okay. So the miners are the people who check that, okay, the data that we got from last transaction is okay according to the consensus of this network, and if that is correct, then they get rewarded for that also, for that validating that transaction. So this is the beauty of the blockchain, Ethereum blockchain, or Bitcoin blockchain, you can say, okay. And the most important thing is on a blockchain is that you can't tamper the data, okay. The blockchain system is hack-proof system. That's why all around the world now people are using this blockchain technology, because you can't tamper the data on a blockchain, right? For example, let's say this is the blockchain system, and say everybody or every miner is working on a block 91, right? Okay, but one of the miners, okay, wants to alter the transaction block 74, right? He wants to alter this block 74 transaction, right? So what he needs to do, he have to make his change and redo all the computations for blocks from 74 to 90, and do block 91, that is 18 blocks, right? So an expensive computing. So if you want to alter the data on a blockchain, you need very high mainframe computers to alter the data on a blockchain. But in the real world right now, it is not possible for any computer in the world to alter the data on Ethereum based blockchain, because it is a already huge network, okay, and you can't afford to alter those data or those transactions on the Ethereum blockchain or any big blockchain network. So this is the main beauty of a blockchain, that it is unhackable, right? So this is all about the blockchain introduction and the history and what is Ethereum network is all about and things. So we will meet in the next lecture. Hello everyone. So in this lecture we are going to see Ethereum history and smart contract. So let's get started with the Ethereum history. So as you can find more information on in the internet, so here is the person called Vitalik Buterin in 2013 published a white paper on Ethereum, okay. And after, in the early 2014, Gavin Wood, who described it properly, okay. And after that, in 2015, the Ethereum network, or Ethereum blockchain, you can say, launched using crowdfunding, right? So this is the just basic history about the Ethereum blockchain. So what is the main difference between the Bitcoin blockchain and the Ethereum blockchain, right? So what are the features that Ethereum blockchain network provides rather than Bitcoin blockchain or other any cryptocurrency related blockchain networks, right? So these are the some features that you can see in the Ethereum. Okay, so first is the Solidity thing. So the Solidity is a programming language built for the Ethereum. So you can write smart contracts, okay, a smart code you can say, in a Solidity language. Okay, so it is a built-in programming in a Ethereum that you can use to write a code. So this is the first feature you can say in Ethereum. After that, Ethereum is a Turing complete, so it can simulate a computer, and it is said to be the most expressive. Means that Ethereum network acts like the computer. Okay, it runs your code. Okay, it saves your data, it get back to your data, it's secure your code and everything just like that. So it is a Turing complete, you can say. After that, a smart contract. So Ethereum network provides us a smart contract, that is a piece of code running on a blockchain. Means that you can write down a program in a Solidity, you can publish that code on this Ethereum network, and you can interact with that code, and that code is called a smart contracts in the language of Ethereum, right? After that, Ethereum provides us a corruption and tamper-proof system, right? So apps based on the network are formed around the principle of consensus, so making the censorship impossible. And because of the consensus algorithm, there is no problem of the corruption in the system, right? So everyone needs to agree on a particular validation, and then that transaction or that particular data will be saved on that Ethereum network. So that is the beauty of this Ethereum blockchain. After that, it is secure, so with no central point of failure, right? So it is secure, you can say, and all the data on a blockchain is cryptographically signed, so that if there is a problem of hacking happened, okay, if someone gets a piece of a blocks from the blockchain, and if he trying to encrypt or decrypt that block, he will not be able to do that, because the data on a blockchain is stored in a cryptography. So he will only see a number of digits and nothing else, right? So that is the best thing, that it is a secure. After that, immutability. So objects code can never be changed. So when you save your smart contract or some data on a blockchain, so it never gets changed by anyone, or it will never change. So that is the thing. After zero downtime, so your apps never go down, okay, or can never be switched off, because as you know, Ethereum network is a blockchain system. So if one node goes down, or if one node goes switched off, still there are other nodes, those have the same copy of that data that you can get from those nodes also. So this is the best thing also. After that, this is a truly global, so you can say the one computer for the entire planet that never goes off, right? So it is a truly global. After that, the ethers. So this is the main crypto fuel, okay, in which we need to pay for gas, okay, to save the data on Ethereum network. So this is the currency or cryptocurrency for the Ethereum network that we need to pay to save particular data. And after that, there is Ethereum wallet. So it's a gateway to decentralized application on Ethereum blockchain. So it holds the ether for the apps, okay. So these are some features that are superior, and those only present in Ethereum blockchain, okay, and these things are not present in a Bitcoin blockchain. That's why Ethereum blockchain is used all over the world for the development of a blockchain related applications, right? So as we see smart contract, so what is actually a smart contract is, and what is the property and behavior of the smart contract? So smart contract is an account controlled by a code, okay. So in the next lectures, when we see that whenever we write down some code, okay, in a Solidity, and when we deploy that code on the Ethereum network, that time we get a particular digits, okay, or address for that particular smart contract, right? So whenever we deploy our smart contract on a network, we get address back, right? So it is a account controlled by code, right? So whenever you want to interact with the smart contract that you have deployed, you need that address, okay. So that is the thing. After that, a smart contract has a properties like it can have the code, it can store your data, it can store your balances, right? So these properties are also presented or is present in a smart contracts. After that, smart contracts can be deployed on a same network with multiple instances, or you can deploy on a multiple networks also. So there are some test networks present on Ethereum, like Ringkeeper test network, Kovan, Ropsten, and Ethereum, right? On those networks you can publish your smart contracts and communicate with your code, right? After that, when smart contracts deployed on any network, then we get a particular address, as I said just earlier, right? So what are the smart contract languages other than Solidity? So as we know, the Solidity is the main language for the Ethereum based blockchain thing, right? The smart Solidity is a contract oriented high level language whose syntax is similar to your JavaScript, and it is specifically designed for the Ethereum virtual machine, okay. But if you don't know about the Solidity language, and if you don't want to learn the Solidity language, then, and if you are familiar with the other languages like Serpent and Python, then also you can write the code in Python and Serpent, and you can publish your smart contracts and dApps on the Ethereum network. There is no problem, because these languages are also supported by the Solidity Ethereum network. And the upcoming smart contract languages are also coming, like Viper, Lisk, and Chain, okay. Those are upcoming smart contract languages that you can use in the future to write down your smart contracts. After that, what are the Ethereum clients? So as I told earlier, that Ethereum is a network having nodes, right? And we published our smart contract on that nodes, okay. But if you want to communicate with the Ethereum smart contract or that particular node, then you need a clients, okay. So there are multiple clients present right now in the world through which you can communicate with your smart contracts. So the clients are like Go Ethereum, MetaMask, Mist Browser, Parity, Ethereum Plus, Ganache, and all those are the clients present through which you can communicate with your blockchain. After that, if you want to download the whole main net or the Ethereum blockchain onto your computer, you can use this get program, okay, that will download the whole blockchain data into your PC, and you can be a part of the Ethereum network also. So these are the some clients that you can use, okay. So this is all for this lecture. We will see the next things in the next lecture. Thanks for watching. Hello everyone. So today we are going to look at this topic, Solidity. So this is the programming language in which we are going to develop our smart contracts for Ethereum network. So Solidity is a programming language, as we discussed in our previous lectures, that Solidity is a high level language and it can support almost all things functions, and it is a very expressive language. So before diving into the practicals about smart contract coding or writing the code, we are going to look at some things of Solidity. So let's get started with the Solidity. So as seen in this image, here is the structure of a Solidity program. So it is the same like any Java file structure or JavaScript class. So here is the header file. After that, here is the contract. So it is just like a class in a Java, and the functions and other things is there. So Solidity is not a very different language from you can say Java or from JavaScript. It is similar to them, but the syntax is different a little bit. So it has a similarity, like it has a same class structure like Java or JavaScript. It supports functions, it supports imports, it has a control structure like if else. Also you can use loops like a for loop or a while loop. Also it supports some data types like uint, that is unsigned integer, boolean, array, struct, mappings, addresses. So these are the similarities which you can find in Java also or in JavaScript also. But there is some differences also, just like Solidity doesn't support float values. Okay, so this is the big difference. So you can't use a float value in a Solidity. The people who are developing Solidity language are working towards it. In the future, it might be possible that you can find a support for float values, but right now it doesn't support float values. Okay, also there is a similarity that you can inherit other functions or other contracts. So this is also possible in Solidity. Also there are some special structure like some modifiers or a modifier class that you can use in this Solidity language. So if you are going to write down some function in a Java or a JavaScript, that may look like the same in Solidity. So this is the Solidity function. So how you can write this? So this is a function. Okay, you have to put some function name here. Then this is the public view. So this is a function type, and it returns a string. So this is a return type, you can say. Then you can open the parenthesis here, and this is a returning some value to the caller function. So this is the same just like you do programming in Java or in JavaScript. There is no too much differences. There are some only basic differences or some additional access modifiers present in Solidity, like pure, payable. Okay, so pure keyword no one used. I haven't seen any smart contract that is used pure keyword, but many people use this payable keyword, okay, or this public, private, view and constant keywords. So we will see what is meant by public. So everyone knows that if you define any class or a method or a function as a public, then anyone can call this function. Okay, so in Solidity you can any other smart contract, okay, that also can call the function which is publicly described. Okay, so anyone call this function. After that there is a private, so only this contract call this function. Okay, so you whenever you write a private keyword before any function or contract, then that contract or a function becomes a private, so only that contract can access those things. After that there is a view keyword. Okay, so this returns data but doesn't modify contract data. Okay, so as you see in this function, that this function is returning some value, some view. Okay, so you can use a view or a constant, both are the same, but just there is a keyword difference. Just many people use view, or many people can use constant also, but they do the same thing. After that there is a payable keyword. So payable, we use payable whenever you want to access some ethers, or you want to get ethers to that function. So that time you use your payable keyword. Okay, so we are going to see all those things in our practical sessions, where we are going to use this payable, private and public keywords. Okay, but right now we are just looking these things theoretically. Okay, then after that, how we can deploy our smart contract. So in earlier lectures, as we mentioned, that we can use different tools to deploy our smart contract on different networks, like Remix. Okay, after that test RPC, Geth, Ganache. Okay, so there are lots of different networks present. So on them we can deploy our smart contract. But how this smart contract actually compile and runs on the network? So whenever we write down a smart contract, then that smart contract will be compiled through any tool, and then we get two files after compilation of the smart contract. First is your bytecode and second is ABI. So we get two files from our compiler, bytecode and ABI. And after that we just deploy our bytecode on our networks. We don't deploy ABI. So what is ABI? So it is application binary interface, which we are going to use, or which people use to communicate with your bytecode, which is deployed on your networks. So whenever JavaScript code or a front end wants to interact with your smart contract, then you have to use that ABI file or ABI code to access the functions or contracts that are present in a bytecode. So what is actually a ABI looks like? So this is the structure of an ABI. So here you can see the structure. It is like a JSON. It's a JSON like structure. So this is a JSON file, you can say, and it contains all the information which you can use to interact with the smart contracts. Without ABI you cannot communicate with the smart contract. So ABI is very important interface we will need in the future also to communicate with our smart contracts. So this is the ABI. After that there is one more thing about the smart contract, that whenever you deploy your smart contract on any network, then please test it before deploying on some Ethereum network or on some test network, because whenever you deploy your smart contracts on those networks, you can't change them. That's why it's not possible to change any code or redeploy at the same address. So that is not possible in Ethereum blockchain. So please test your application and do proper programming before deployment. So I will say test properly before deployment. So these are some points that you need to remember before diving into the writing of code. So these are some points, so please take care of these points. And in the next lecture, now we are going to dive into our smart contract things with the remix. So thanks for watching. Hello everyone, so today we are going to cover a little bit of basics related to web3.js. What is actually web3.js and why we require web3.js. Okay, so first of all, this is the JavaScript file, okay, that we will required to interact with the blockchain. Okay, so everyone knows that Ethereum is a node based system, right? So on every node there is a copy of a blockchain, right? So whenever you have to pull up some information from the Ethereum blockchain or from that particular node, that time you have to query to that particular node about that data. Okay, and because of that we need to write the queries to pull up those data. Okay, but Ethereum nodes only speak a language called JSON RPC. Okay, they don't speak a JavaScript language or any high level language. Okay, so they speak JSON RPC. Okay, so here you can see that this is the JSON RPC code that I have mentioned here. Okay, so as you can see that this JSON RPC code is not a human readable. Okay, it is a very complex code that we cannot use to pull up the data, because we cannot write such a data. That's why there should be another way so that we can interact with this nodes, okay, or this JSON RPC. So because of this problem, actually whatever maybe the problem faced by the developers, they developed this web3.js JavaScript. Okay, it's a JavaScript which they use to interact with this JSON RPC. Okay, so web3.js hides these nasty queries below the surface, so you only need to interact with the convenient and easily readable JavaScript interface. Okay, so you can only have to write down the code in a JavaScript. Here you can see that this is the JavaScript code. This is a very human readable, and you can do this coding by yourself also. It is a not complex one, and there is a not too much amount of data here. So this is like a URL to the remote web server for your API calls, okay, in a traditional web app. Okay, so everyone knows that if we develop an iOS app, okay, and whenever we want to interact with some server, we need an address of the server or web APIs. Okay, from those web APIs we can pull up or send the data to the particular server. So just like that, this web3.js actually help us to get or send the data, or it will help us to interact with the Ethereum blockchain. Okay, so but how we are going to talk to the Ethereum based blockchain or that particular data? So in the last lecture, I think so, we have seen that the folder structure and how we are going to install this front folder and all that stuff we have seen in the last lecture. In that folders also, there is a one particular folder that we have made that is called the contracts. And what we have done in that contracts folder, that we copy some JSON files from the build folder that we have compiled earlier, right? And we have copies those JSON files, those we got after the compilation, and we copy those files and paste that files or those JSON files into our that contracts folder, right? So why we did that? Because those are all ABI's files. Okay, so as I mentioned that there is a JSON RPC thing, okay, and we cannot interact with the JSON RPC directly, so we need an ABI. to interact with the code, data. So because of that, we need ABI, and then web3.js will talk to this ABI, and then this ABI will talk to that particular blockchain. Okay, so this is the flow of this. Okay, so basically it's as I just mentioned, it's a representation of your contracts. Okay, that is a Solidity code, but that Solidity code gets converted to .json format, and that JSON format you can understand. Okay, after that there are many numerous things by which you can interact with these Ethereum nodes also. So some of the ways are like you can write down the code in your or that script in your project, and you can interact with that particular node also. Okay, or you can use things like MetaMask or third-party tools like Infura or something like that to interact with this Ethereum nodes. Okay, so also that if you want to talk to this blockchain nodes, that time you also need the port numbers, right? For Ethereum main blockchain, or for the test RPC, you have the port 8545, and for the Ganesh you have the port 7545. Okay, so and the main thing here is that your blockchain node must be running to talk to that node, because if blockchain or that particular machine is off, then you cannot talk to that particular blockchain using web3 or any ways, right? So this is the thing. Okay, so let me tell you about the tools, okay, of this. Like I told you about the MetaMask, so you can go to this Chrome store, web store, and in this web store go to this extensions. In this project we are not using the MetaMask for any of our transactions. We are going to directly use our scripts in our code, but many of the applications in the future that we are going to build, or you can see on internet, you will find this MetaMask thing. So just find this MetaMask. Okay, and just click on this MetaMask. So here you will find this extension, and yes, just you have to install this. I have already added this MetaMask here. Okay, so this has just an accounts. You have to give your passwords, and so they will create the accounts on the MetaMask. So this is the Chrome based or Firefox based extension that you can use to interact with the blockchains. You does not need to code anything or something like that. This is the third party and very good tool which is developed by this metamask.io. So this is very helpful tool that you can use. After that, there are some also subnet of the Ethereum, like Infura, that you can use. Okay, let me show you. So this is the scalable blockchain infrastructure that you can use for your Ethereum based projects. Okay, so many of the time what is the problem that people get is that if you want to actually run or download the actual Ethereum main node, so that time you will get the problem of syncing, because the main Ethereum node is actually very huge. I think it's probably current size of the Ethereum blockchain is around 70 to 80 GB, okay, gigabytes. So that is a very huge, and so people will get very tired, and they get very bored because of the sync problem between your nodes and the main node. So many of the time people actually go for this infura. Okay, so by using this thing you can also able to interact with the main node. So this is a free thing, so you can go and just inject their one line of code into your project, and you will be able to interact with this. Okay, so in the next lecture we are going to use this web3.js to interact with our contracts. So we will meet in the next lecture. Thanks. Hello everyone. So today we are going to look at some theoretical lecture about what are the types of variable that can be supported by the Solidity, because we need to understand this variable section and the coding structures that has been supported by this Solidity language. So before deep dive into this lecture, I am going to install a visual code into my system, and that software we are going to use for our development purpose. So let's get started and find the visual code. You can go to this Visual Studio Code website here. So website is open. Here you will find a button, download for Windows. So whatever may be your operating system, go and download this stable version. So my operating system is a Windows x64 based, so I'm going to install this software into my system. So go and install this stable version. So first let me download this. So now it is downloading here. Okay, so it is now downloaded on my desktop. So go to desktop and do the setup of this visual code. So now it is doing its setup. So just wait for a while. Just click on this launch visual code and finish it. So it is a free software that you can use as your editor to code the Solidity programs and smart contracts. So now it is opening here. It will just take some time for the first time. Okay, so actually this Visual Studio Code actually made for the Microsoft C hash codes and something like that, but it can support the languages like here you can see JavaScript, TypeScript, Python, PHP, Azure, Docker and more. So for those language highlighting, you can use their extensions. So now we are going to use this Solidity language in this visual code. So we can go and install their extension from their store. So you can find the store extensions. So click on this extensions here, and here you'll find the top extensions that you can install into this Visual Studio Code editor. Okay, so like Python, C, C++ and other languages, but we are interested in Solidity, so find the extension for Solidity. So here is the first Solidity version that you can install. Just click on this install button. Now here you can see it is showing me that it is installing into my Visual Studio Code editor. So actually if you even doesn't install this extension into your this Visual Studio Code, then there is no problem actually. But why I am actually installing this software? Because it highlights the syntax, the correct syntax for the Solidity. Just like here you can see that the syntax highlighting, snippets, okay, compilation of the current contract. So this can be possible with this Solidity extension here. So this will help you to understand the highlighting of the Solidity program, their contracts and other things. So if you wish to install this, you can go and install this extension into your Visual Studio Code, or you can use any other editor for this. It sometimes takes some time because it's a little bit huge extension. That is why it is taking some time, I think so. Okay, but it is taking okay. So now it is done with the extension. So just close this. Okay, so as we discussed earlier in this thing, that we are going to look at the types of variables supported by this Solidity language. So what we can do is that we can go to the file, new file. This time typing that I am not writing down any Solidity code here. Okay, I am just showing you what are the types supported by the Solidity language. So the strings, as you know, the variable type supported by Solidity. Let me zoom this. So first is a string. Everyone knows that string, like hi, hello. So these are the string which is supported by Java and other programming languages. So Solidity also supports a string type of variables. And after that, it also supports a Boolean, like true and false values. After that, it also supports integer, like as we know, 0, minus 100 and 100 and plus value like 100. It has a new you can say variable that is very important and that is widely used in Solidity, that is called unsigned integer, that is uint. This is unsigned integer. So it has only positive values, it supports only positive values, means that you have only 0 and 100, but you cannot have minus 100 here values, only positive value it supports, positive values it supports. Okay, so after that, float is not supported by the Solidity. Okay, and there is also a new variable called address, so which gives you the address of the owners and senders and everything in the format like 0x8465367 something like this. Okay, so these are the some variable types that it's supported by the Solidity language. Okay, so if we go into the deep about this, like integer and uint, their ranges. So let me give you some details about those. Okay, so what is the main difference between this integer and uinteger range? So many of the people you know that integer starts with integer value like 8, after that integer 16 is there, after that integer 32 is there, and so on, and last value is the integer 256. Okay, and as you know, integer 8 only supports up to minus 128 to upper value is 127, and integer 16 supports from minus 32,768 to upper value plus 32,768. Okay, so just like that, the number goes on increasing at both the end, at the negative end also and at the positive end also. Okay, like into 56, integer 256 supports really big number, big negative number, you can say negative number, and at a plus side, upper side, it is a really big positive number. So this is the main difference between the integer 8 and integer 256, that their range is different. Okay, so actually many of you use only integer, you never use like integer 8 and integer 256. So integer is as same like integer 256, both are the same. So in many examples in Solidity also you can find integer or integer 256. Okay, so both are the same, there is no difference between this. Okay, but as we discussed that there is a uint, that is unsigned integer. Okay, that is also supported by the Solidity. So it has also, it starts with uint 8, its lower value is 0 always, and upper value is 255, and uint 16, its lower value is also 0 and upper value is 65,535. Okay, and just like the same way in integer, it supports uint 256 and its initial value is also 0, but positive value is really big positive number. So uint only supports a positive number, it doesn't support any negative number. So in Solidity many of the people uses this uint 256. So in our program also we are going to use this uint 256, or you can use uint sorry, I have some spelling mistake here. So uint, and so uint, and that is same as uint 256. So it is also the same, that is uinteger is equal to uinteger 256. So you can use any of these things. Okay, so as we have seen that in this lecture that it supports many different types of variable like string, boolean, integer, uint, and addresses. Okay, and we have gone some in details for the integer and what is the uint. Okay, so it is just a variable supporting video, actually what the variable it supports. So in the next lecture we are going to see another things that it's supported by the Solidity, like mappings and struct, and what is the message variable. Okay, so that we are going to see in the next lecture. Thanks for watching. So today we are continuing our last lecture. In last lecture we have seen that what are the variable types supported by Solidity. So in this section I am going to show you what are the structures and what are the new types of things that is supported by this Solidity. So first I will show you the message variable. Okay, so you can say it is a global variable. So what is a message variable in a Solidity is that it has the address of the contract. Okay, you can have this message variable accessible wherever you wanted in the code. So this is a global variable by default, so you can call this message variable in any function or in any constructor. Okay, so this gives you the address of the owner who is either sending the money or sending the ether, or the address of the contract. So you will see this message variable many of the times in Solidity language. So always remember that this variable is a global variable and that can be accessed anywhere in the program. So this is the by default variable that has been given by the Solidity to us that we can use in our programs. So another things that Solidity gave us is a mapping. So mapping is a collection of key value pairs. It is just a collection of key value pairs. Okay, all the keys in a mappings must have of the same type. Okay, just like for example mapping. So this is the syntax for mapping: string, okay, or mapping integer and boolean. So it is a collection of key value pairs. Okay, many of people know that this is also used in other languages, but their name is or syntax is different. Okay, so in Java, like you can say it is a hash. Okay, in Python you can call it as a dictionaries. Okay, something like that. Okay, but in Solidity we are going to call it as a mapping. Okay, so it is a collection of key value pairs, and as I said, all keys must be of the same time and all values must be of the same time. Okay, so this is the mapping. And if you want to use a collection of key value pairs that has a different types of values or keys, then you can go for the struct. Okay, so it is a collection of key value pairs that can have different types. Okay, for example, let me give an example. Okay, first write down it's also a collection of key value pair but of different types. So for example, you can have a struct car, and in that you can have a string make string model and event value. So as you can see here that it is a structure of a different key value pairs. So here you can use a string Okay, and you can also use event or boolean or any other variable type. Okay, so it will give you the different types of uh, structure that you can use as a variable in your program. So this is another things that is given by this solidity. So in our program also we are going to use this struct thing and the mappings thing and message also. So this is it for this lecture. So we are going to see the program in the next lecture. Thanks for watching. Hello everyone. So in this lecture we are going to see about the information regarding ERC20 token, because in our exchange we are going to use this ERC20 fungible token for our exchange. So for that and for the more information you can Google it. Okay, so I'm going to Google it for the ERC20 token, and here you'll find some of the information. And if you go to this website, that is the Ethereum wiki. Okay, this is the unofficial site for ERC20 standard token. So this is the very famous and the first very popular token in the world, on which many of the ICOs and exchanges are actually built upon. So this is the very famous token. So, and this is the page where you will find the updated information and other things on this page. Okay, so let me explain you step by step what is ERC20 token is all about. Okay, so ERC20 token is an Ethereum standard protocol for token generation. Okay, in ERC20 what you can do is that you can make virtual tokens of a same type. Okay, means every token is not a different one, every token is the same. Okay, it's just like your $10 bill. Okay, like if you go to anywhere in the US, and if you find a $10 bill has the same value everywhere in the US, right? So its value is the same. So every $10 bill is its value is equal to $10 everywhere in the US, right? So those are all same bills, right? Same here for the ERC20 token also. If we generate some tokens using this standard format ERC20, then you will have the same type of token of the same shape, you can say, of the same value, of the same thing, of same properties, same characteristics. Okay, and they have the same value throughout the standard, right? So this is the main functionality of this ERC20 token standard, right? So how we can build any token supply, or how we can generate or mint a token from this ERC20, right? So for that here you will find a standard interface here. So this is the main interface that actually gives us the functionality that we require for our token generation. So here you will find the functions, events and contracts, like, okay. So in these functions and these events you can use to generate your own tokens using this ERC20, right? So here you will find that your every token must have some name. Okay, just for example they have given the name that is token name. Okay, and every token should have a symbol. So whatever may be the symbol that you want to give, you can give it here. Okay, and after this is the decimal. So here is the decimal, that is 18. 18 is the most common number of decimal places. So these are the things that actually already this ERC20 standard token provides to us for the generation. Okay, So let me show you how actually this contract works. Okay, so if we go to this here things here, the contract token fragment, okay, here we will find some mappings and balances of and transfer functions. Okay, so you can copy this contract from here also, and you can run this contract into Remix and check out the things, how this function actually works. So let me explain it for you. So if you go to this page in the below section, there you'll find an example. Okay, so here they have given an example of this ERC20 standard token contract. Okay, so here they have given us two account, that is, this is your first account and this is your second account. Okay, this is the address for the first account and this is the address for second account. So first account has the balance of 100 tokens, you can say, and second account have the balance of 200 tokens. Okay, and now if you want to check the balances of these accounts using this interface, then what you can do is that you can call this function, that is the balances of function, and you can pass the address of the token owner. Okay, and that will returns you the balance. Okay, so this function, you will find it here, they have written down the code for this. Okay, so here you will find the function balances of, you need to pass the owner's address, and in returns you will get the balance of that particular owner. So here what they have shown us, that you can call this balance of function using the contract instance. So this is the contract instance by using which I am calling this balance of function for this particular address, and it will return me 100 tokens, and for the second address it will return me 200 tokens. Okay, so how this is how actually this balance of functions work. Okay, after that, if you want to transfer some tokens from account 1 to account 2, okay, here also they have given us an example for this transfer function. Okay, so if account 1 wants to transfer 10 tokens to account 2, okay, then how this contract will actually going to work, and what is the code for that we need to write down for this, right? So for that, what we have to do is that we have to call this transfer function. Okay, so this is the transfer function here. So here you will find that it is taking the address of a 2, okay, the address to which you want to send the tokens and the number of tokens that you want to send to that particular address, and this will returns a boolean value to you as a success or not. Okay, and this is the function they have written for this transfer. So this is the function for this transfer thing that you will find it here. So whenever you call this function, transfer function, what happened is that this is the code. So I am transferring to this account 10 tokens. Okay, so after the transfer becomes successful, you can go and check the balances of this particular addresses again, and you will find that, okay, so address 1 should have the balance of 90, and address 2 should have balance of 210, because 10 tokens we have transferred from account 1 to account 2 using this transfer function, right? And for that you can use, for checking the balance, you can use this balance of function. Okay, and after that, here you will find some other things like approve and transfer from token. Okay, so here is an example for approve. Okay, so if your account 1 wants to authorize accounts 2 to transfer some tokens to account 2, okay, right? So that time account 1 will execute this function, that is approve functions, right? So how this approve function will work? So here account 1 will execute this approve function by using the address to which it is approving that how much tokens account 2 can spend in the name of account 1. So account 1 is allowing account 2 to spend 30 tokens in the name of account 1. Okay, right? So this is the thing. So now account what actually account 2 can do is that account 2 can spend up to 30 tokens in the name of account 1, and that is this approve function is all about. Okay, and after that there is a function that is called and transfer from function. Okay, so here is an example for this transfer from function. So if account 2 wants to later transfer some tokens from account 1 to itself, okay, so that time it executes this transfer function. So here you will find this is the function that we have called it, they have called it here. So this is the address of account 1, this is the address of account 2, and this is the number of tokens that address 2 wants to transfer later, okay, to itself from account 1, right? So those 20 tokens will be transferred from account 1 to account 2 by account 2, because this contract is called by this account 2, right? And at that time you can use this transfer from function, and after that you can check the balances of all those things. Okay, right? And this is also a sample. Here they have given the whole sample for this ERC20 token up here. Okay, you can check out this sample in a remix. So this is sample has all the functions here. They have given us a sample, so you can go and copy and paste this sample into the remix and you can check it for yourself. So this is all about the Ethereum ERC20 token standard and how this is the function and this is the contract for this. Okay, so in our exchange also we are going to use this ERC20 interface for our tokens. So we will meet in the next lecture and we will see the next topic. Thanks for watching. So hello everyone. So in this lecture what we are going to do is that we are going to check this ERC20 smart contracts example in a remix. So you will get an idea of the remix also and how to run the your smart contracts into remix. And for that what we are going to do is that we are going to copy this sample token supply, okay, and we are going to paste this sample token supply with some functions. Okay, some functions we are not going to check. Okay, like this, there are some unwanted functions now added in this smart contract, so we are not going to test them. Okay, just like this, transfer any ERC20 tokens and approve and call these things. So I have already copied this smart contract into my notepad. So now let me go to the remix, and for the remix you have to go to this website, that is remix.ethereum.org, and from here you can do the testing for your Solidity smart contracts. So what you can do is that here you will find all the things. So this is the browser based ID, right? So okay, so first of all let me show you the some slides regarding the remix, their features and what are the things that actually the remix provides. So let me go through that first. Okay, so what is actually remix ID is it's a browser based ID in a cloud. Okay, and Remix ID is used for smart contract development. It is the best tool you can have to write down your smart contracts before writing down in some other softwares, because Remix has some very good features, like it has an integrated debugger, integrated testing environment, it has a static analysis, and it can also deploy your contracts on some testing networks also. And what is the good part of Remix is that it also works with the MetaMask or Mist. If you don't know about the MetaMask or Mist, then don't worry about that. In the upcoming lectures, I will show you what is a MetaMask or a Mist. Okay, and if you want to check out the site, you can go to this link, that is remix.ethereum.org. Okay, so now we are come back from our Remix slides. So now we are going to test that fixed token supply sample code in this Remix Solidity browser based ID. Okay, so I have already copied that code into my notepad. So the same code I am going to paste. So this is the pre-generated code that I need to remove this. So just select and remove and paste your code here. Okay, so now I have already pasted code here, and here you'll find all those things, like you can compile this Solidity smart contract, okay, from this panel. Okay, and you can run, you can analyze the things, you can test, you can debug, and all the things you can do with your smart contracts. You does not need any other software to check out your smart contract. This is the best thing actually this Ethereum company has provided to us. This is that is the Remix. Okay, so for now we are going to test this fixed token supply contract. So let me compile this first. So you can go here and you can click on this start compile button. So now it is compiled and it is showing me some warnings. So these are just warnings. Okay, it is like here it is giving me like error warning that invoking events without emit prefix is deprecated. Means that some of the things now has an updated in this Remix browser compiler also. That's why it is showing me that some of the things that are deprecated. So you can do is that you can emit those functions and you can use that function as it is. So just for that they are giving me an error for this transfer message. Okay, so I'm going to write down emit for that. After that, same for approval. So find the approval function. So this is an approval. So again save this. Okay, and start the compilation again. Okay, and these are some other things that I need to check out. There may be some other transfer function. Okay, but these things doesn't matter to us actually. Okay, but in this code here you'll find that this is the fixed supply token contract example thing. Okay, and they have given the symbol for this token as a fixed, and the name of this token is the example fixed supply token. Okay, and the total supply is around 10 million here, and other code and other functions here. So now let me show you how actually we run this code in this Remix. So just go to this run tab, and here we'll find the environment. Like this is the environment. Okay, so this is the JavaScript virtual machine which is already presented here. This is the injected web3. So whenever you want to work with the MetaMask, that time you can use this injected web3. and this is the web3 provider. So whenever you have any script that you want to run from the code, that time you can use the web3 provider. Okay, so for our example, I'm going to use this local JavaScript virtual machine for our testing. So this is the JavaScript virtual machine, and these are the 5 accounts here with 100 ether each. So these are the 5 dummy accounts which are pre-loaded with 100 ethers each. So we can use those ethers for the gas supply, and we can generate the tokens from this, right? And we can transfer the tokens between these accounts also. And this is the default gas limit they have already given. So, and this is the value. If your function has some payable keyword, means that whenever you call that function, and if that function is a payable, you need to transfer some ethers or some value, okay, by using this. So you can pass the value using this, but in our function there is no payable functions written, and so for that I am not going to pass any value. And after that, here you can see the token interfaces and the contract. So first, this is my first contract, that is ERC20 interface, and this is my second contract, that is a fixed supply token. Okay, that's why it is showing me 2 contracts here. Okay, so first is only interface, so we cannot deploy this interface because the interface does not have any functions. Okay, so all the functions are written down in this fixed supply token, right? So here you will find all the functions are written down in this fixed supply token contract. So we need to deploy this fixed supply token. So I am going to click on this, and after that I need to click on this deploy button. Then okay, so here you will find that my fixed supply token contract now has been deployed on this JavaScript virtual machines and at account 1. Okay, here you will see my account is now deducted with some ethers, because those ethers actually taken by this remix ID to run this and to deploy this smart contract on this JavaScript virtual machine. Okay, that is the amount of gas they need, and they have deducted from the ether. Okay, and now this is the memory address at which it is now deployed. Okay, so as we have seen that whenever you deploy a smart contract on some blockchain or some Ethereum's virtual machine or something like that, you will get an address for that particular smart contract. So this is the same thing here. So at this address it is actually deployed, and if you pull this up, here you will find the details. Okay, so here this is the green thing, means that our function is actually executed successfully. And for the more details, you can open this thing and you can see how much gas, transaction gas it cost us. Okay, and all the things. So this is the console where we will get the results, like if it is a succeeded or not, what are the problems and everything, and from here you can debug also. Okay, so but right now we don't faced any problems. Okay, so now we are going to check all these things. So we will start with this total supply. So our total supply that we have mentioned here is that around 10 million. So when I click on this button, I should get the 10 million total supply of the tokens. Okay, so let me click on this. Okay, so it is, this operation is also successful, and here you'll find that my token fixed supply token contract has a 10 million token supply. Okay, and after that I can also check the symbol. So this is the symbol, that is a fixed. After that I can check the owner's address. Okay, so owner's address will be this address, that is a 0x692, that it should show me, because the owners of this contract is this address. Okay, so sorry, not this thing. This is the address. This is the address on which it is actually deployed, and this is the owner's address. Sorry for that. So 0xCA3. So this is the owner's address from which it is deployed. Okay, and after that the name. So example fixed supply token. So this is the same here. After that the decimals it will show is 0, right? And if we need to check the balance of the first owner, okay, what we can go do is that we can copy the first address. Okay, so this is the copy, and we can paste it up here, and we can check the balance of things, and here you'll find 10 million tokens actually this account holds. And if we go to the second address, you can check for the second address, copy this, and so I think it should return as the 0 because account 2 doesn't have any tokens, right? Because right, so it is showing me the balance of for account 2 is a 0. So after that what we can do is that we can transfer some tokens from account 1 to account 2. So for that we need the address of account 2. So this is the account 2 address that I need to copy, then I need to paste up here, and I need to pass the number of tokens. If I am going to pass like 500 tokens, just click me on this transfer. Okay, my operation is successful now. Okay, and if I go to account 2 now, and if I check the balance of account 2, I think it should show me, sorry, I need to check with this. So now this is the transfer function that you can check it here. Okay, so you need to pass the address of the account 2. So you can copy here, you can paste it here, and you can pass like 500 tokens, and it will show you the success. Okay, so this is how you can test all these functions and all other things in this fixed supply token smart contract. Okay, so this is just an example that they have given us, so you can go and you can check all those functions by yourself. Okay, they have already given the explanation for each and every line of code and things. Okay, so you can use this token supply example to learn more from this thing. Okay, so this is it for the remix. So in the next lecture we will start with our exchange, and thanks for hello everyone. So today we are going to start with some concepts regarding our projects. So actually, what is the main difference between ERC20 and ERC721? So in this lecture we are going to see what is ERC means, what is fungibility, and what is the main difference between ERC20 and ERC721. So let's get started with the difference. So actually many of the people you have I think read about, or you have seen some games on ERC721, but I think so many of the people you don't know about what is ERC721. So first of all we will start with the game that is called CryptoKitties. So it is based on ERC721 protocol. Okay, so actually this CryptoKitties apps developed in last year, and it has reportedly seen around $20 million of Ether spent on buying and trading of various unique digital cats on its platform. So it is a decentralized app, and it became so popular that people went crazy, for this kittens actually, and they are buying and trading these kittens on this platform. So it is a totally ERC721 based game. So when you say fungibility, so what is meant by fungibility actually? Because ERC20, as you many of them know, that ERC20 contract is a fungible contract, and ERC721 is a non-fungible contract. So what is the main difference between this fungibility? So we will go to this google.com and we will find some information regarding ERC721 token. Okay, so if we go to their main site, that is ERC721.org, here you will find some information regarding ERC721 protocol. Okay, so as you see in this image that ERC20 contract has identical tokens, means all the tokens are of the same value, but in ERC721 each token has a unique value, means no two tokens will be the same in ERC721. So on this concept actually these people developed some games like crypto celebrities, crypto kitties, and ether tulips. So actually this game also needs such a concept. So ERC721 gives these concepts to these games actually, because like in crypto kitties each cat should be different from another cat. So this ERC721 protocol helps to define or make a difference between each and every cat. So people can breed them and generate new cats, but those are not different. But those are different actually, sorry. And hence they can sell them and they can trade them on the over the internet actually. So as just we have mentioned that the fungibility, so ERC721 is a non-fungible thing actually. So many of the people does not know what is ERC stands for. So it is a Ethereum request for comments. So it is a Ethereum you can say name authorized name by the you can say ERC is an authorized by Ethereum community developers in the form of memorandum describing methods, behaviors, and research or innovations applicable to the working of the Ethereum ecosystem. So it is you can say a standard. That's why you will find ERC20, ERC721 and ERC1155 such as standards. Okay, so now actually we have to look at the difference. Okay, so now first we will see what is ERC20 protocol. So it is the most common and well-known standard within all crypto community, right? Because 99% of the ICOs that has been published in 2017 are all based on this ERC20 protocol. So this protocol actually makes the same type of token who has the same value. You can say that's just like a US dollar. Each US dollar of the same value has the same value. Okay, so ERC20 provides this functionality to the program that whatever may be the token, it has the same value. Okay, so all the tokens are of the same value. So the key benefit we get here is that any application or other smart contracts can interact with the token in a standard manner without need of knowing other details about the token. Okay, and therefore we have a very pleasant way to create any ICO token and have a standard way to interact with all of them like they are all the same. Okay, but this is okay for whenever you have to launch your ICO. Okay, but whenever you have to give some difference to the people, that time you have to choose something else. So that solution is your ERC721. So the goal of this proposal or ERC721 is to create non-fungible token, means that no tokens will be the same. So as we know, in ERC20 standard we have same tokens, but in ERC721 no tokens will be the same. So this makes it easy to trade tokens, as all of the token supply can be treated in the same manner. However, there are various cases when you need to have unidentical tokens, like ERC721. Okay, so that time you can use this ERC721 token. So this is a non-fungible token you can have. So by design, ERC721 tokens are each given a unique and indivisible set of properties. They are unequal to other tokens on its blockchain. Okay, so this is the main advantage of this ERC721 actually, that the differentiation, okay, and inequality between tokens, means that the token, each and every token has some unique value. They are unique to each other. So besides the token, you can develop some other concepts on this ERC721 protocol, like the people who did the crypto kitties, ether tulips, and crypto celebrities. So you can also develop a game like crypto doggies, such like that, because as doggies are also this same concept actually. So you can go and you can find the more information on this or more information on this ERC721.org. okay, so as I mentioned that you can develop a game on doggies also. So as you know that that there are, and they will many people have the dogs, but that dog is theirs and they will not accept some other dogs as a substitute. So you can use ERC721 tokens to represent those dogs and dogs ownership. So you can develop such a games on this concept. So this is the main difference between ERC20 and ERC721. So you can find more documentation on Google. You can find there are lots of material present on the Google, so that you can explore. Okay, but for our project this is the enough knowledge, I think so. So we will see the implementation of this protocol in the next lecture. Thanks. Hello everyone. So in the today's lecture we are going to see difference between ERC20, ERC721 and ERC875, and what is actually the difference between these three ERC protocols and at what functions they differ. So let's get started with the ERC20 first. So you can go to the google.com and you can find lots of resources available for ERC20 token. All right, so if you go to the Google and type that ERC20, there are lots of resources available on internet. Okay, and you can go to this website, and okay, so this is the Ethereum website on which you can find this ERC20 token standard. So as of many of you know that ERC20 is the first token standard that was published by the Ethereum, and this is a very super hit token protocol, and still people use this protocol for their token based contracts and functions. Okay, so this is a fungible token, means that in ERC20 whenever you mint a token, so all the tokens are the same and they have the same value. Okay, so if you go to the website here and find out the functions here, and these are some functions, and this is the contract here, ERC20 interface, and functions like total supply, balance of allowance, transfer, approve, transfer from, and these are the events. Okay, so what is the main difference between ERC20 and then ERC721 and ERC875? So why they need to go for these next protocols, right? Because ERC20 is also a very standard interface they have provided. But the problem with the ERC20 token is that just I mentioned that it is a fungible token, right? Means all the tokens that you are going to mint from this contract have the same value, have the same properties. Okay, so if anyone wants to different tokens with a different value, with a different properties, so that time ERC20 has some limitations, right? You cannot create a non-fungible tokens, means you cannot create a different and unique tokens in ERC20, and that's why developers needed to move from ERC20 to the next protocol, and they invented this ERC721 protocol, and that is a very huge hit again for the people who needed such a protocol, right? So if you go to the google.com again, and if you type ERC721, and if you go to this website of ERC721, you will find the description, and here you can see this like difference between ERC20 and ERC721, sorry, that a class of identical tokens are generated in ERC20 and a class of unique tokens are generated in ERC721, as you can see from these images also. So in ERC20 you will get same images or identical tokens. Okay, there is no difference, but in ERC721 you will get every time a new token. Those and not two tokens are not same at any point. Okay, so here you can see the image, and this is the interface for ERC721. Okay, this has the same functionality as of ERC20. Okay, but just there are some little bit of difference regarding the token IDs and some parameters they have passed into this interface. So that is just a difference. Okay, and on this ERC721 many games have been developed, like crypto celebrities, crypto kitties, and ether tulips, right? And those are very hit games, and people have gathered some amount of money from these games, and these games are possible because of only because of this ERC721 protocol, because it provides very unique things, right? Like if you go to the cryptokitties.com, cryptokitties.com, and there you will find this all game is based on this ERC721 protocols. And what is this game is all about? Here you can have to breed very different and unique adorable kittens here, and those are unique, and after that after you breed those kittens you can bless them for the sale, and people purchase those kitties for very large amount, right? And that's why it is very hit game on the internet right now. Okay, but we are interested in this course regarding ERC875. So what is the difference between then ERC721 and ERC ERC875, right? So actually there is a not too much amount of difference between ERC721 and ERC875, right? Because ERC is an also standard non-fungible tokens, and ERC721 is also a non-fungible token, right? Means that ERC721 and ERC875, these both the tokens actually produce a non-fungible tokens, means their output will be the same. You will get every time the unique token, okay, right? So why there is a need to produce this ERC875 protocol for these tokens, right? So actually the problem with the ERC721 is that whenever you want to sell some tokens, that time the seller also need to pay the gas, and buyer also need to pay the gas for the transactions, right? And that is a very huge problem for the Ethereum network, because they clog the network because of this gas fees, and you can't sell batches of tokens at one point in ERC721, and those problems are actually eradicated and removed in the ERC875, and other functionalities are the same. Okay, if you go to google.com and you will find, if you find ERC875, and you to go, if you go to some of the pages like their GitHub pages, okay, here you'll find that ERC875 is a non-fungible tokens with the simple atomic swaps. Okay, so what is that? Okay, so if you go to the functions here, so the same functions actually you will find in ERC20, ERC721 and ERC875. so same functions are also here, like name, symbol, balance of, transfer, transfer from, total supply, owners of, right? All these functions are also present in your ERC721, right? But there is a difference of this atomic swap, and you can call it as a trade function. So this is the difference between ERC21 and 721, sorry, and ERC875. Okay, so this new trade function is they injected in this protocol, right? So this is the new function in the 875, and this is a very beneficial function because as you can see in this documentation, this function actually a function which allows a user to sell a batch of non-fungible tokens without paying for the gas fee. Only buyer has to pay the gas, okay, in a P2P atomic swaps, right? And this is achieved by signing an attestation containing the amount of tokens to sell, the contract address and expiry timestamp, the price prefix containing the ERC's spec name and chain ID. So this is the only difference between your trade function in ERC875. Okay, in this ERC875, the seller does not need to pay the gas, only buyer need to pay the gas for the transfer, right? And in the trade function you can sell a batch of non-fungible tokens at the same point. Like if you have 10 unique non-fungible tokens in your account, and that you want to sell those 10 non-fungible tokens in a one shot, then just you need to give those things on the ICOs or something like exchanges, okay, and you does not need to pay anything. Okay, the buyer will pay the gas fees for those tokens, and he can also buy 10 tokens at the same point with the same amount of gas. Okay, that is the beauty of this trade function that they have produced in this ERC875 thing. Okay, but all other functions and all other things are the same, right? For more details you can Google this. Okay, there are not too much of documentation available right now on the internet on this ERC875, because it's a very latest ERC protocol they have just produced, right? So that's why on internet there are not too much amount of documentation you will find. Okay, but in the future you will find many examples and things on the internet, right? So there are some GitHub pages for its 875 protocol that you can read, like this one. There are some issues pages also, where you can find many things they have discussed about this and what is the difference between these protocols. Here someone asked this question, right? So you can search more on this on the internet, right? And in this course we are going to see all this functionality using the remix. Okay, like trade function, we are going to test this trade function using the remix IDE, because on remix it will be easier for us to show you the how we are going to use this trade function to sell these things, right? So all these functions we are going to test in our remix IDE. Okay, also if you want to know more about the other functions like this balance of and transfer from, you can go to this ERC20 token standard, because these things are same here, right? So for example, if you want to check the balance of a function, okay, so here they have given example, like there are two accounts, this is the first account and this is the second account, with the first account have the balance of 100 units and second has the balance of 200 units, right? Okay, and if you use this function like of this balance of function, here it will return the balance of a particular token owner. Okay, so you need to pass the token owner's address here. So as you can see here that they have passed this owner's address to this function, and it will return you the amount of token or the units that account has, right? After that there is a transfer token balance also. So in that if one account want to send or transfer some token to the another account, that time you can use it use this transfer function, right? Here they have given example, right, for like this. Okay, so if you go to this transfer function, you have to pass the address of the buyer and the number of tokens you want to pass or transfer, right? So here is the thing, and for example the account 1 wants to transfer 10 tokens to account 2, that time they will execute this function like this, transfer and account of the second address and the amount of tokens that you want to transfer, right? And after that if you call this balance function again, that time it will return you the 90 and 210 tokens for that accounts, right? So here are some examples, and these are the same things that you will find like balance of function, right? You need to pass the owner's address here, and this is the same transfer function that is also present in ERC20, right? Because we are in route right now in ERC875, and here you will find it is the same like ERC721 and ERC20. Okay, just difference is only that here you are passing the array, right? Here you are only passing the one address, right, and one amount here. Okay, but here you are passing the array of tokens, means a set of tokens you can transfer at a one point. So it is also taking two parameters here. So all these functions are same, just as I mentioned, only this function is different from other two protocols. So in the next lecture we are going to see about all these functions in a remix and all those stuff. Okay, so we will meet in the next lecture. Thanks for watching. Hello, welcome to this lecture. So in this lecture we will continue our journey with ERC20 token standards. Okay, so in this lecture I am going to show you what are the different types of ERC20 token standards that we are going to implement, right? So as we see that there are major ERC20 and ERC721 and 223, 875 and 1155 token standard are popular in the industry right now, right? So before deep diving down into the ERC20 token standards and implementing in the remix, so before that let me give some little bit idea about each and every ERC20 token and other ERC token standards, right? So ERC20 token, as you can say, that it is a fungible token. So fungible. So what is meant by a fungible token? So fungible means that if you make any token with the help of ERC20 token standard, then that token will be the same. Like if you go to the showroom of any car, and if you find that from first car to up to the last car, all cars are the same, so that thing you can say that all cars are fungible, means they are all the same value of the same property, right, of the same color and everything, right? So that is why this is called a fungible token, means all the tokens that are generated with this ERC20 will be the same and they will have the same value, right? So, it's just like that you are exchanging the currency like US dollars with the US dollars. So each so $1 of USD dollar you can exchange with another one USD dollar will be the same, right? So this is the fungible type of ERC thing. So whenever you have to do some exchange work, or if you need to generate some tokens for some purpose, that time you use this ERC20 token standards, right? So after that another token that comes is that ERC721 standard, and that is called a non-fungible token standards, right? So what is the problem with the ERC20 is that only a similar type of tokens can be generated with that standard, right? But many people found out that that is a constraint for the ERC20, right? So they developed another protocol that is called ERC721. So this is a non-fungible, means that you have different types of coins or tokens that you can generate in this with this protocol or ERC721 standard, right? So no coins or no things will be the same, right? So in our program also we are going to implement this ERC721 token contract, and I will show you how this things actually work, right? So this ERC721 by using this token standard, what you can use, that you can attach some properties, you can attach tables, you can attach anything that is present in this world, right? So that is the beauty of this ERC721, that so that you can develop many applications based on this ERC721, like property a property exchange, property bazaar, something like that. So this is a very helpful ERC token standards right now in the world, but there are also flaws for this, so that is covered in the next standards, right? So as I said to you that there are lots of problems with ERC20 and ERC721. Not a problem, but you can say a constraint, right? So those constraints are removed in the next token standard. So just there are some constraints present in ERC20, those are removed in ERC223. So what is ERC223? So ERC223 is just like the same way of ERC 20, right? If you go to the google.com and if you find ERC223, okay, and we will go to this ERC223 token standard. Let me go to this token standard, and we will go to this page here, or their official GitHub page. So here you'll find the code of this thing is very much same like ERC20, but there is just a little bit of difference of the receiving things. Means that in the ERC20, if you build any token or a coin, and if you send to a wrong address, that time you cannot get back that token from that particular address. So means that your token will be locked there forever and you can't retrieve that token. So in the last year, like just you can see that here they have said that ERC20 token suffers critical problems. Just I mentioned that critical problems, and that caused loss of approximately $30 million at this moment, up till this date, right? So this is the main disadvantage of this ERC20, and that is removed in this ERC223. So what happened in the ERC223 is that in ERC223, if you send any transaction to a particular address, and if that address is not compatible with your token or a coin, then that transaction is actually cancelled by that address, and that thing will be returned to the sender's address again. So there will be no loss of tokens. Contract token standard you can use rather than ERC20 for your project, right? After that there is ERC875, but before that let me go to this ERC721 also. So here you find many different things of ERC721 here. So here also they have mentioned the ERC20. So here you can find the similar type of tokens, identical tokens, and ERC721 generates a unique type of tokens, right? So this is the main difference between these two, and this we will cover in depth in the next lecture, what is the difference between the ERC20 and ERC21, right? So first of all we will start with our ERC20, and I will show you that what is ERC20 token standards and how we are going to use this code in the remix, and what is a remix is all about. So we will meet in the next lecture. Thanks for watching. Hello, welcome to this lecture. So in this lecture what we are going to see is that what is the ERC875 and ERC1155 is all about, right? So as we see things with the ERC721, that is, it is a non-fungible, right? But there are also constraints for that ERC721 thing, right? So that is actually removed in 875, or you can say improved in 875. So if you go to the ERC 875, and if you go to the ERC875 page here. So here you can find that it has the same functions that are present in the ERC721. Okay, but there is just a simple new functions, that is the trade function that is introduced in this ERC875, right? So this trade function allows a user to sell a batch of non-fungible tokens without paying for the gas fee. Okay, so only buyer has to spend the some amount, right? So this is the P2P atomic swap, you can say. So this function is actually introduced in this ERC875, and this is a very beneficial function that is present in this 875. All other things like balance of transfer and all the stuff is the same like ERC721, and we are going to see the things of ERC875 in this also in detail, right? After that there is another protocol that is present, is ERC1155. This is the new protocol that is just introduced by this ERC people, right? So here you can find that the ERC 1155 things. Okay, and this ENJ is the thing that is actually focusing on this ERC1155 protocol mainly, right? They are implementing various things on this protocol, right? For more information you can go to their website about this ERC token standard, right? And they have given an example here about the games, right? Because main problem with the ERC721 is that if you build a contract for one thing, then you cannot use that the same contract for another thing. Means for example, in a simple words, you need to buy separate mobile for each mobile app. So this is the thing with the ERC721, right? So that problem has been resolved in this ERC1155. So here for example they have given an example of a game here. So like there are 1,000 types of different items present in your game, like swords, peoples, buildings and other stuff. Like there are thousands of things present in your game. Then in the ERC21 you need to deploy different 1,000 different smart contracts for that particular game, right? But in 1155 you just need to define those game persons, buildings and swords and stuff like that in a single contract, and that you can use within a single smart contract. You does not need to build different types of smart contracts each and every time, right? So this is the thing that they have given here. So you can go to this website and find the different things. Also this atomic swaps is there, multi-transfer you can use, right? And here you can see that you can have different accounts, and you can have different types of like arrows, battle axe and things that are connected to each and every account, and that you can transfer between each other. So this is the thing and the good thing present in this ERC1155, right? So this is the very new protocol that is just introduced by this ERC token standard, right? So in the next lecture we will see these things in more details. Right now, thanks for watching. Hi everyone. So today we are going to set up the npm packages, the truffle and ganache for our software development things. So in this lecture we are going to start with npm. So let's open a notepad here and go to this website node.js.org, and there you will be find a version 8.11.4 LTS, that is a stable version that you need to install. Now it is downloading. So it is not a big one, so it is around 15 MB, so it will get downloaded. And if you want to check their version, so you can add these following commands that I am mentioning in this notepad, that is node -v and npm -v. So this command will give you the versions. Okay, now we are going to set up this node.js into our system. So install it. So just I'm checking those packages here. I'm installing the full node.js package, so click on next here and install. So it is now installing. It is copying some files. Wait for some time because it depends on your system how much time it will take to do the setup. So now click on finish. Now go to command prompt and run our commands node -v and npm -v. So you will get the version numbers there. Now we need to install truffle. So go to command prompt and we need to install this by using this command npm install -g truffle. So just paste this command into your command prompt and it will install. So now we need to download Ganache also. So you have to go to this truffle framework website that is I'm mentioning in this notepad. So I'm going to this website. Okay, so here you will find a Ganache GitHub repo. So go to the GitHub repo there. Okay, click on Windows download and it will go take you to this, and then click on this Ganache setup 1.2.exe. Okay, so it will be get downloaded to your system. So this downloading will take some time. So what we can do is that we can also check the truffle and solidity version by using the command that I am mentioning in this notepad. So this is the command, truffle version. So just copy this and run it into your command prompt, and you will get this truffle and solidity versions. So now I am downloading the ganache here below, you can see, but it will take some time because of my internet speed. So we will catch up when it is downloaded, and then we will continue that thing. So now it is downloaded here. I'm opening it. I need to set up this, so just install this here. So now click on finish. And this is the ganache that is in opening here. So just press on continue here. Okay, so this is a ganache. So ganache is a private network, you can say. This is your RPC local server. So it has 10 accounts that you can use to test your smart contracts. So we will work with smart contracts and ganache in the next lecture. So thanks for watching.
Hello everyone. So in today's lecture we are going to write down some code for ERC875 smart contract. Okay, for that we can go to google.com and we will find ERC875. Okay, we will go to its GitHub pages, and here you will find the specifications for the ERC875 non-fungible token. So this is the interface that we are going to write down in our code. Okay, so for that I will use Visual Studio Code, right? So I'm not making any changes to my previously created project, that is our truffle files. Okay, I am just going to write down code in a single file, and we will take up that code and we are going to take that code to the Remix ID browser based ID, and there we will put that code, and we are going to test everything that is specified here. All those functions we are going to run on Remix. Okay, because it's easy for us to run every specification or every function on Remix rather than on Truffle, right? Because if you want to test everything, those are mentioned functions in this contract, then you need to write down a very large or big program for this, and for that it's easy way to you can have that is that you can write some small amount of code, okay, some functions, and you can take up that code and put that code onto the remix and you can test. Okay, so first of all we need to write down the code for that. Okay, so first of all I will create a file here, so just make a new file here and save it here. So I'm making its name ERC.sol. Okay, so I have now created the file erc.sol, that is a solidity file, and after that I can write the code in that. So contract ERC. Okay, and in that contract you can write the code that is mentioned here, or you can just copy and paste this code. Okay, so I am going to copy this code from the GitHub pages. Okay, all the functions that are defined here. So this is the standard functions that these protocol supports. So you does not remember, it doesn't need to remember anything. You just need to copy and paste this code here, and these are the optional functions. Okay, so in this tutorial we are not making any ICO or something like that, so we don't need this total supply functions, so that I'm not going to use for this program. And after that you can have your owners of function and the trade function. So the important function that we are going to test for this ERC875, and that is the trade function. It is the different function from your ERC20 and ERC721, right? And this is the main function that is introduced in this ERC875 protocol. Okay, so I'm going to use this trade function and just copy and paste it here. Okay, and we also need the events for transfer. Okay, but that is not mentioned here, so let's find out that event also. So go to the google.com and find the GitHub pages. There also you will find. Okay, so these are the event also, so you can go here, and we need this event, and I will declare on the first of line this. Okay, so only these functions we are going to test, and the main function that we already write down here, right? That is your trade function. That is the main function that we are going to test in this, right? And okay, so now we have done with our ERC contract interface right here. After that, what I need to do is that I need to write down a code that will interact with this contract. Okay, so what you can do is that you can make another file, and that in that file you can write down that code. But for example purpose, I'm just going to write down that code in this same file. Okay, so you can have this pragma solidity compiler version dt 0.4.23. we are using the latest version, that is a 23 for our project. And you can write down your contract, give it the name of the contract, and A is ERC. So we are referring this ERC here, right? Okay, and in this now I am going to write down some code that we need to test all these functions here. Okay, and for that I need to, first of all I need to declare some variables for this. Okay, so just I'm going to declare some functions, and I'm writing down the code for that. So unit address and it is an array of inventory, and now we need to uint 16, or you can use 256. Okay, ticket index. Okay, so to track the mapping in tickets, I am declaring this uint here. So here is spelling mistake. Okay, you can have to track mapping in tickets. Okay, so you will get understanding of this. And after that uint expiry stamp. Okay, so all these variables that we are need, because of they are already present in their interface, like this timestamp, owner, okay, value of admin, total indices and everything. That's why I need to declare, and I need to use those things here also. Okay, and I need the owner address of the owner. Okay, so this will the address that calls self destruct and takes fees. And I also need the address of admin. I need also uint transfer fees to check out this trade function or transfer function. After that uint transfer, and I am initializing its value to 0. After that I need two strings here. First is your string public name and string public symbol, okay, for your token, and name for your token that we are going to use, okay, that we are going to store in these string variables. And after that, event 8 public constant so these are the some variables that I have mentioned here. Okay, in the next lecture we will continue with this code. Okay, so these are the just variable that I have declared. After that I need to write down some more code. Okay, so we will meet in the next lecture and we will continue with this. Thanks for watching. Hello everyone, so we are continuing our last lecture, that is we are writing down code for our smart contract to test out this interface function. Okay, so if you want to write down this code, you can write down this code, or you will find the GitHub pages for this code also. Okay, so if you go to this link on GitHub, you will find this code also, because it is produced by the owners of ERC875, and those are the contributors. They have published this code on their GitHub pages also, or you will find the links on the internet also. So you can go to this ERC token implementation.sol, and from here also you can copy this code. Okay, so in the last lecture we have actually written down this amount of code. Okay, and in this lecture I am going to just copy this code. Okay, so let's copy this code from here and we'll paste it here. So there is also an explanation for this they have given here, right? Okay, so for example they have declared the modifier here. Okay, so they are checking the message.sender's address that should not be equal to your admin address. If that admin address is same, okay, then that will give you an error, or it will revert, right? So after that they made a function that is a public revert, right? And they don't want to send it in ether directly, so for that they done this function here. Okay, and the main function that we are interested in this token function. Okay, because in this token function we are actually saving the array of the number of tokens. Okay, for example this is the number of arrays that you can save here. Okay, and after that the string name, expiry, event symbol and admin address, all these things are declared in this token function. Okay, and those things are assigned particular to each and every variable, right? Like just like expiry timestamp and expiry, that is it will get from this arguments, right? Then owner's address and all these things we will pass from our input text boxes, and those will be passed here, right? And after that here we'll find the trade function. Okay, and in this trade function they are taking and passing this value. We need to pass the expiry of the tokens, the token indices, how many tokens we need to trade, okay, and after that this is the V, R, and this is the S. Okay, so if you go to the Google and if you go to their GitHub pages, here we'll find that VRS actually is the cryptographic sign or digital cryptographic sign that is used in this ERC875. Okay, here they have explanation given. So no one can fool the system, or no one can trade the older orders. To check those things, they have produced this value of VRS. Okay, those are cryptographic sign. Okay, and for that we have a code that we can go there, and we will also able to generate that cryptographic sign. Okay, so here they have checked all these things, and after that they have state function will run, right? And after that the encoding of the message and other things for this program they have written down it up here. Okay, so what we can do is that we can copy this thing from here, and we can go to the remix. Okay, just I need to go to this remix ID, and in this file I need to paste these things here. Okay, so now I have pasted all the code here. So in the next lecture we are going to test these functions properly with the remix, and then how we will check out that how we are going to implement the things, and how we are going to test this smart contract properly. So we will meet in the next lecture. Thanks for
Hello everyone. So in the last lecture we have copied and pasted this ERC875 contract in our remix browser. So in the today's lecture we are going to continue with that same smart contract, and we are going to test all the functionality that is provided by this smart contract on the remix IDE. So let's get started with it. So now we have copied and pasted our code here. Now I need to compile this code before deployment. So this is the compiler where you can select your different compiler versions according to whatever maybe your compiler that you are using. Okay, so I am going to use the latest one, whatever may be the compiler given by the remix ID. So I am selecting the newer and the latest version, and after that I am going to click on this button that is just start to compile, and there are some warnings, okay, but no errors are there. Okay, so this is my first contract and this is the token contract. Okay, now I will go into the run tab and we will deploy this. Okay, so let me adjust this so you can see clearly, and let me do this. Okay, so now I need to run this code. So this is the token contract, because this is just an interface, that's why I'm not going to deploy this. Okay, because I'm using this interface in this token contract. So my main contract is the token. Okay, so for that choose the environment JavaScript virtual machine, your account or whatever maybe your first account, gas limit, everything. Okay, and whenever you choose this token, and there you'll find some parameters that you will need to pass to run this smart contract. Okay, so for this you need some things. Okay, so I'm going to copy the example here. So this is the input that I'm going to paste here, so just copy here from here and paste. So these are the number of tokens that I am passing. I am passing the 15 tokens in an array. After that it is asking me the event symbol, sorry, event name. So this is just an example. What you can put whatever you want to put in here, so just put here. After that there is an expiry time, that is, this is in milliseconds, so just put that there. And after that event symbol, and then there is an address. Okay, but we need our address, so our address is different. Okay, this is an just example address, but this is our address actual, so you can copy it from here. So just copy and paste it here. Okay, and let me adjust this also, so you can see clearly what is happening with the transaction. So then click on this transact button, and here you'll find our transaction is get successful, and our contract has been deployed on this address, right? Here you will see the green sign. Okay, and for the details you can open up this tab here, and there you will find all the things that has been decoded as input. Okay, so now I can expand this, because now my token contract is been deployed. Here you will find different functions that we have written in this, and that are present in this smart contract. Okay, so some of the functions we can check now. So just like what is the symbol, so this is the symbol that we have passed, right? MJC. After that our symbol name, you can click on this button and you will get MJ come back, right? After that you can check your balance also. So this is your balance, right? We have transferred 15 tokens. Is our contract expired? We should get a false result, because our contract is not expired. Yeah, it is giving me a boolean expression that is a false. Okay, after that get decimals is of no use maximum, but we can click on that because here we didn't give any decimals tokens, that's why it is giving me a 0. After that get a contract address, so you will get this address on which we have deployed, right? 0x692 0x692. After that get amount transferred, so we need to do some operations for this. Okay, symbols. Okay, so I can also check the balance of a particular address if I want. Okay, so for that, this is my contract address and this is the owner, right? If I need to check the balance of this particular owner, then I just need to copy and paste their addresses here and I can check their balances, right? So it has from 1 to 15 tokens, right? And after that what we can do is that we can transfer some tokens to the other address. Okay, so here are some addresses. So this is my first address and this is my second, third, fourth, fifth, right? So now what I am going to do is that I will transfer some token from my first address to say this second address. Okay, so I need to go to this transfer tab. Okay, here you can see a to and token indices function. Okay, to is the address of the buyer. Okay, means the second address. So you can copy
this is the second address. Just copy the value from here and paste it here, and the token indices. So if I want to give 10 and 11 two tokens to this particular address, if I want to transfer this, okay, and choose your owner's address, because owner can only do the transactions. Okay, so choose your owner's address and do the transact. Okay, so our operation is successful and we have successfully transferred this tokens to this address. If we need to check the address for this, so we should get 2 tokens for this address. Okay, just put that address here in balance of, that is 160C. Okay, here you can see the address 160C, and you can click balance of, and here you'll see 11 and 12 because it's a token indices. So this is the address, not the token actual. So address 10 and 11 has the value of 11 and 12. Okay, that's why it is showing me and 11 and 12 value. Okay, this is just address that I have passed here, and this is the value for this 11 and 12. Means at a 10th position you have an 11th value, and 11th position you have 12 value, right? So these tokens have been successfully transferred here. Okay, after that you can also check this transfer from here. You need some addresses. Okay, so the first address is from address, second is your the address to which it needs to be transferred, and third is your token indices, right? So let's go and do this operation also. So I am going to copy this address, so I will paste this. Now I will choose the third address here, okay, to which I want to send the tokens, and here I will send 8 and 9 number indices. Okay, and do the transact. Okay, so it has given me an error, some error. So okay, so what is the problem is that I haven't chosen this address of the owner, because I am transferring from this address, and this is the contract address. So please, whenever you check with this such a smart contracts, always choose the deployed address or the owner's address. Okay, right? Because if you don't choose, you will get such an error here. So now again I will do the click on this transact button. Okay, so now you can see our operation is successful, right? Succeeded, you can see. And now you can check the balance for this third address from your, just copy and paste that address and check that, right? You get the 2 tokens from here, right? So this is how you can check the all the functions for this smart contract. Okay, so another thing that we need to check is the main function, that is a trade function. Okay, and for this function is very actually tedious function, because it needs to be a cryptographically encrypted function, it needs to be a cryptographically signed function. That's why we need to generate these 2 values, 3 values, V, R, S, right? So for that we need to use some program to generate that cryptographically signed things, and then we will put that things here. Okay, so now another thing that you can use, that if you deploy these smart contracts on a Rinky, okay,
So you can also test this function very easily, because on a local test network it will give you some problems. So for that, what you can do is that you can put these smart contracts on a Rinky, okay, and you can check this trade function very easily, okay. For now, I will show you if someone has deployed any smart contracts on a Rinky, and then how you can use their addresses to fetch that smart contracts into the remix, right? So for that, what you need to do is that, okay, I need to go to this GitHub pages, okay. So this GitHub page, and here you will find, so test out here, they have already given you this Rinky address on which they have deployed this smart contract. So we does not need to deploy the smart contracts on a Rinky. So what we can do is that we can use this address for our deployment and other things, okay. So just copy this address from here, copy, go to your Remix browser, okay, just wrap up these things. So this is my first contract. Now what I am going to do is that I will deploy this token, okay, and fetch this token from particular address, okay. So Remix will give you this functionality that you can pull up some contract from any address. So this is the address field where you have to put that address that you have just copied or you get from the Rinky. So just put that things here and click at address. So here you will find that my address is now been fetched from 0005, and if you go to this pages, this is the address, that is 0005. So we have successfully fetched this thing from the Rinky. And now what you can do is that you can test all these functions as we have already tested before, right? So but we have already tested the get symbol and buy balance and everything, okay, in this local address, but for now we have to test this trade function. So for that, what you need is to provide all these value, and you need to generate all these value from some Java file or some code, okay. So on these GitHub pages already they have given the code for that, okay. So if you go to this example and just click on that, and this is the code in Java, okay, on which they have they are generating the value of things, okay. So some things are fixed, but some things are like these three things they are generating here from here, but some things are fixed, like token indices are fixed, expiry is fixed, just like that, okay. So what you can do is that you can copy this code, or I already have copied that code. So let me open that in my notepad. Just go to the Java compiler, online Java compiler. So I'm going to this Java compiler. This is the online compiler that you can use. You does not need to install any program to generate this program's output, this Java program's output. So now I have copied my Java code from my file, okay. So the same code you can find it here. So you also can copy this code from here and put it there. Okay, just change the address here because it's local address, and I need to give this 005 address here. So this is the just address, and this needs an external library, because if you are going to run this code without this any external library, then you will get an errors for this Web3.js crypto libraries, because these are external libraries they have used here. Okay, so what I'm going to do is that I will go here and I will add my external library. So you can also copy these three things from here. So your group ID is org.web3j. After that, second is the crypto, your artifact ID. So you will find this library online also. I have already just copied the things from that library to my notepad and just click on add. Okay, now my go and check that your external, right, my external library is now added. Okay, and then just I need to click on this execute button. So just click on this execute button. Okay, so here you will get the cryptographically signed VRS values. Okay, that you can copy and put it in the trade function, because if you go to this trade function, you need all those value, and then your operation will be successful, or else you will get an error, because it should match up with this output, whatever maybe the values that you get here. Okay, just like 1 0. So I'm going to put those value. My expiry is what? My expiry is 0. My expiry is 0. So my index is 3 and 4. So token indices you have to put in array. So 3, 4. After that you need to v value, that is a 28. So 28. So copy the value of R, put it here in the R section, and copy the value of S and put it here, S. Okay, and now we will do the transact. So just click on this transact function, right? Okay, you get a succeeded. Here you will get a message that your operation has been successfully mined and execution is succeeded. So because in a trade function, the function checked that these expiry tokens and VRS values should be the same that which we have generated here. Okay, then we can trade the function, trade the tokens, or else we cannot trade the tokens. Okay, so this is the main trade function that we have seen. Okay, and these are the main values like VRS and expiry time. Okay, for example, we have expiry time, we have set it for 0, but for the real project you need to set some expiry time, and you need to generate this VRS value for that particular real time project, and that's how you can secure your trade function with this. Okay, so this is all for now in this lecture. That we have what we have seen in this is that we have implemented all these things in the smart contracts. Okay, and we have run and compiled all these functions. We have checked all these things. Okay, like transfer from, balance of, trade function, and everything we have seen in this lecture. And we have also checked that how you can fetch a smart contract from the particular deployed address. Okay, so all these things we have seen in this lecture. So this is it for this lecture. In the next lecture, what we are going to see is that we are going to implement some interface functions, okay, some 1 or 2 3 functions from this smart contract or this interface, and then we are going to mint a token that is a unique token, okay. In that smart contract we are not going to trade and transfer all those functions things, we are not implementing those things, but we are going to see that how we can generate a unique token, okay, because ERC875 gives us a non-fungible token, okay. And in this lecture already we have seen all this functionality.
Hi everyone, so today we are going to look at our project. So we are starting with our project. So we have to write down some smart contracts in a truffle. So in last lecture we have installed a truffle, so now we have to start with our project directory, and we are going to check how to create the files for our smart contracts and how to use truffle. So let's get started with command prompt. So I am opening a command prompt here, okay. So now what we have to do is that we have to make one directory there. So go to your particular drive, cd any drive, okay. I am going to the core of my drive by using cd dot dot. Now I am going to make a directory here, token. So here you will find a token directory is now been created. Now I have to go to this directory by using this command cd token, and now I am in the token folder. Here I have to initialize my truffle project here. So the command for initialization of the truffle is like this, truffle init. So just run this command. So whenever you run this command, it download and unpacks some folders, okay. So it will give you the project structure, project files that you can use for your project. So now we are going to open those files, but for those files you need some editor to open those files and to write the code in those files. So now we'll go to some editor. I'm going to use a visual code in this project. So go to google.com and find visual code. You can use any other editors also, but I prefer this because it's an easy. So you go to this link and you can download this stable version, okay. My PC is Windows 64, that's why I am using this, okay. So I am already downloaded and installed this visual code in my PC. So I'm not going to again install this software. So now just I am going to open this software and I will show you the folder structure, okay. So now I open this Visual Studio Code software. So this is the interface for this. Okay, so now what I have to do is that I have to open this folder that we have just created in a C drive. Okay, this is a token folder that we have created using the command prompt here. Okay, so just open this, select a folder, and here you will find that your project is opened here. So there are some folders which was created in the command prompt automatically by using this command. So you does not need to make this folder manually. So we are going to look at these folders, like what is the contracts, migrations and test. Okay, so this contract folder is where we are going to keep our Solidity files or write down our smart contract codes. So this folder we are going to use for our smart contracts. Okay, after that there is a migration folder which is used to deploy our smart contract script that can be used to deploy our smart contracts on particular networks. Okay, after that there is a test folder that can be used to test out our smart contract code. In this folder we have to make some test files and run that test files to check whether our contracts are okay or not. After that there is a truffle config file and there is a truffle.js file. So this file contains the network code on which you want to deploy your smart contract. If we want to read more information about the structures and files, then you can go to the Truffle website. So that is a Truffle framework here, and you can go to the docs, and in that to just click on this Truffle, and here you will find creating a project with the Truffle. So as I just mentioned the steps in this video, those steps you will find here also. So just like make some directory, then go to that directory and use this command, truffle init command. Okay, so I have used this command, and there are some more documents or information you can get from here. So like Solidity contracts, script table deployment files, and configuration of files. So all the documentation is available on this website, so you can go to this website anytime and you can read in more details on this website. So on the next lecture we are going to write down our smart contracts in the Truffle, and we are going to test and deploy them in the upcoming lectures. So we will meet in the next lecture. Hello everyone. So today we are going to start with our project here. So today we are going to write down ERC721 contract. First of all, we are going to write down some code, that is a ERC721 standard contract. Okay, and for this project we have already covered the basics of Solidity and the blockchain in our previous lectures. So now in this lecture we are going to implement this ERC721 contract. So let's get started with the ERC721. So first of all, if you want to know more about what are the standards, those are supported by ERC. So you can go to this website. This is the ERC20 token, and this is the GitHub pages. Here you will find the ERC721 standard protocol. So actually we have already discussed ERC20 and ERC721 in our previous lecture, but if you go to this website, ERC20 token standard, there you can find the contract interface here. This is the ERC20 interface. Okay, these contract have the same functions that is present in your ERC721 contract, like transfer, approval, everything. Okay, actually these are both are the same token standards, you can say, but as we have mentioned in our earlier lecture, is that there is only difference of the tokenization. Means that in ERC20 you will get the same token every time, but in ERC721 you will get separate or different token every time whenever you mint the new token. So that is the main difference between ERC20 and ERC721, but the functionality of both the contracts are same, their functions are same, they work same, everything they do the same things. Okay, so now we are going to write down the code for ERC721 in our Visual Code Studio. As we have seen in earlier lecture that we have generated our project in truffle, that is a truffle init command. So this is the project. Okay, so that time I have shown you these files and folders, so contract, migration, test, and truffle.js and everything. So whenever we have to write down some contracts, then we have to choose this folder, that is a contracts. So there is a migrations.sol, that is a solidity file, that is a pre-defined by the solidity or truffle. You will get this file this file will be already present in your project every time. So this is the test file, so we don't have to worry about this file. So just close this file and create your new file, that is ERC721.sol. SOL. So this is the extension that we use for our ERC or solidity files. So now you can go and write down pragma, then solidity, upper arrow character 0.4.17 or 18, whatever the version you want to use, you can use that. Okay, first of all it will give you some errors, but after some time that error will be gone. Okay, so now what we have to write down is that contract ERC721, open your curly braces. Okay, so we have now write down our contract ERC721, and in that we have to copy and paste some things, like these are the events and some are the functions. Okay, so here you can have this event, you can copy this event from here, or you can write that code. Okay, so I am going to write that code. So that is event transfer, in that address indexed from address indexed _2 and unsigned integer, that is unsigned. I am going to use this unsigned integer 256 to store my token ID. Sorry. So right now I am just writing down my code here. I will explain that code after some time. Just first of all write down some code, and then we will get to know what is actually this events and functions is all about. Okay, so just let me write down more code for this approval. Sorry, indexed owner. This is token ID. So as we have write down the code here, okay, so as you go to this interface on this website, okay, this is the website. So if you go to the standard template there, here you will find an event transfer function, okay, that we have just written, and this is the event approval function. So both are the same, okay, just there are some variable changes, okay. So this is the same actually here. So what is actually an event is? So in a Solidity, event is like a lock, okay. Whenever you want to lock something into your programming, that time you are going to use this event keyword. So maximum time programmers use this event for like at the transfer and at the approval time. So they will get to know what is actually happening in the program and what are the transactions and everything. They will get to know by this lock. So whenever you want to use this event, so just remember that events are nothing but a locks in a Solidity. So in a standard template here you can find that the two events they have mentioned, and this is a third one, but we are not going to use this, okay. So just we are going to use these two events, those are important to us. And ERC721 also you will find these only two things, like event transfer and event approval, okay. So only these two we are going to use in our program. So just remember that these are the just log to log your transfers. So where is the things going from one account to another account, and approvals. So this is the just event function. In next section we are going to write down some functions. Those are the standard functions which are here in ERC721, and we are going to explain those functions also. So we will see in the next lecture. Thanks for watching. So hello everyone. So now in the last lecture we have seen this event transfer function and event approval function. So now we are going to write down some functions for this ERC721 standard token contract. Okay, before that, as you've seen here, there is an error here, okay. So this error is of the indentation, only use indent of 4 spaces. So you can remove this in a Visual Studio Code by going to clicking on this CRLF, okay, and just choose LF here, okay, and your errors will be gone, okay. So now we will go to our functions, okay. As we are seeing here that ERC720 and ERC721, there are similar functions here like balance of and transfer and approve. So same functions are present here like balance of, owners of, okay. Just the names are changes here, okay. So we are going to use these functions in our project. So write down some functions, or you can copy them from their sites, okay. So just function, balance of address owner. Okay, so here you can see this code, function balance of address of underscore owner, and here they are using now the external keyword, but we are going to use the public keyword. Okay, so we can access everything from any contract in our project. So we are going to use public. If anybody wants to use external also, they can use external or internal, depending upon whatever maybe their requirements according to the project. But for our demo project, I am going to use this public keyword, so it will be easy for us to get the access of these functions in other smart contract. So I am going to use this public keyword, and after that view, it will returns unsigned integer balance. Okay, we are going to see these functions in the upcoming time. So actually, sorry, it's the problem here. So another function is a function owner of okay. So again, if you go to this website, there is like the functions balance of, owner of, okay, and many functions are here, approve and all, but we are not going to use all the functions from this ERC721 standard token contract. We are going to use only some of the functions or some of the line of codes from this ERC721 contract. So go to our code editor again and write down some more functions before explaining them. It's just a public. After that, function approve, ID public, and okay, so these are the some functions that we are going to use in our project. So now we are going to see what is actually these functions work. Okay, so go to the website here. So in this website you will find a very little bit about explanation about this contract. Okay, so But you can go to this ERC20 token standard contract and you will find the explanation for these calls. Okay, so as they have given us an example for the token balance, okay, for this function. Okay, so the balance of function. So as you can see here that they have taken it to addresses. Okay, this is the first address and this is the second address, and first address have the balance of 100 units and second account has the balance of 200 units. Okay, so whenever someone calls this balance of function, so what they actually pass the address of owner. Okay, and in the return they will get the balance of that address owner. Okay, so here you can see that this is the balance function and this is the address that we have passed here. Okay, and it gives us the 100 okay unit, and this is the balance for the second address. And whenever we call this function balance of, we will get the return of their balances. Like we have the 100 units balance for the first address and 200 units balance of the second address. So this balance of function actually returns the balance of the address owner or anyone's address. Okay, so this is the very basic functions that gives us the balance. Okay, and after that there is a function called transfer. Here you can see this is the transfer function. So in this function, if there is a first address and first address wants to transfer 10 tokens to second address, okay, then first address will execute this function, transfer function. Okay, so this will call this function transfer, and this transfer function gets executed, and here we will find that the balances of the first address is equal to 90, okay, and the balance of the second address is 210, because transfer functions, whenever it invokes the core, it will transfer some amount of tokens to the second address, you can say. So here we will find the code for that. Okay, so we are also going to transfer some things from here and there, so we can use that transfer function. Okay, and after that there is an approve function here. So approve means that if address 1 wants to authorize address 2 to transfer some tokens to address 2, okay, so that time address 1 will execute this function. Okay, means that if address 1 wants to authorize some address 2 function, that it can spend some amount of token for him for account 1, then what the code look like is that, okay, so the code will look like that. Okay, token contract approve, this is the address of the second, and it is allowing 30 tokens to be approved from account 1. So account 2 can spend 30 tokens in the name of account 1. So account 1 is approving account 2 to transfer or withdraw some funds from his accounts. Okay, and they address 2 can spend that tokens anywhere he wanted. Okay, so this is the approve function. Okay, so we have also write down that function here. Okay, and another function is there, is that is a function owner of. Okay, what is this function actually is doing? That it is taking the tokens ID as a parameter, and it is returning the address of the owner. Okay, in our program in ERC721 we have different types of token, right? So all tokens are different. So if there is a one user or one address, okay, and he has like 2-3 different types of tokens, okay, or if we wanted if we have the token ID and we want to get the address of the owner for that particular token, then we can use this owner of function here. So just we have to pass the token ID and it will return us the address of that owner. Okay, so this is the standard template for ERC721 that we are going to use in our project. Okay, so in the next lecture we are going to implement the functions for this ERC721 standard token contract. So we will see you in the next lecture. Thanks for watching. Hello everyone. So today we are continuing our project here. So in the last lecture we have seen that ERC721 standard token template, and we have write down some code from their website. Here you can see that code. We have written some events and functions. In today's lecture we are going to write down some new files and code required to implement those functions that is written here. Okay, so let's get started with the new file. That file is going to contain the main logic behind our project. So that is a very important file that we are going to write down. So first we need to create it. So just go to your contracts folder and click on this new file and put the name ERC721 token.sol. Okay, and after that we need to write down pragma, a solidity compiler version, solidity Puraro character 0.4.18. Okay, and after that we have to write down the contract ERC721 token is ERC721. So actually we have inherited this contract, the main contract, from here. Okay, so after that we have to we actually need some files to work with this project. So that is the file called a safe math that we need to use in this project. So what is actually a safe math file is the safe math is a solidity math library that is specially designed to support safe math operations. Safe means that it prevents overflow when working with unsigned integer. Okay, and that file you can find on Google. Okay, so go to the Google and find safe math library, and here you will find the links on OpenZeppelin GitHub repo. So this is the file that we are going to use in our project to do some our safe math operations. So you can copy this file from here as it is, and after that you need to create another new file called safemath.sol, and you need to paste it here in the error of this editor. So just click here and click on this LF, okay, and go to our previous file also and just change to LF here, okay. So after that we need to write down some using a safe math line of code. So we are telling our compiler that we are using this safe math library in this smart contract. So this is giving me an error here, so we need to import those files here. So first we need to, and we are also getting here because they are not getting the references, okay. So I need to import those files. So import in double quotes ERC721.sol and import in double quotes safemath.sol, okay. Okay, after that we need to write down some code here, but as many of you seen that I have some errors before writing down this code. That is that for this ERC721 and for this safe math, so those are compiler errors. So actually I paused that video for some time and did some research on that, and I found that there was an compiler error. So I gone to this safe math file and changes my compiler from 18 to 23 here, and for also my this file, that is my file ERC721, I am changing this to 23. So after saving this compiler version, my error is gone now. So if you also get an error with ERC721 here and for safe math, then please go and change the Solidity compiler version to 23 in safe math and ERC721. So okay, so let's continue with our coding actually. So now we have to declare some variables to store token owner's address and list of owned tokens by addresses. So for this we need some variables and the mappings that we are going to use in this project. So let's write down the code for that. So here I am going to write down some mapping. So mapping to 56, sorry, and address private token owner. So actually I am declaring this mapping for to get a particular token for a particular owner, okay. So we will pass the token ID to this mapping, and this mapping will return the address of the token owner, okay. After that we need to
we need another mapping, that is mapping. Okay, I am writing down code first. So address, and after that event 256, and I am assigning a dynamic array here. So I am using this dynamic array because I need to store the list of tokens owned by the addresses. Okay, so private, I am making this mappings private, tokens. So actually this code here is the in this step actually what we are going to look at, that this variable has a token owned by a specific address, and we will pass the owner's address to this mapping, and it will return a list of tokens owned by the addresses. So this code is for that. After that we need write down some min functions and other things. So those functions we are going to write down in the next lecture. For right now, thanks for watching. Hello everyone. So now in this lecture we are going to continue with our code that we have left in the last lecture. So in this lecture now we have to write down a mint function. So a mint function is used to create a new token. So this mint function or a minting is used in every token contract, whether it is based on ERC20 or whether it is based on ERC721. Okay, so it is the basic function of every token contract. So we need to write down the mint function so that we can create a new tokens with the unique ID in our project. So for that we need to write down a function. So I am going to write down a function for that. So function mint underscore mint, and it is taking two parameters, that is address of message.sender, that is meant by the creator of this contract, and unsigned integer 56 token ID, and I am making this public. And just open your curly braces. So here you will find there is a green line here. So it is because of the unused function. We need to write down some code for that, then this green line will disappear from here. So now we have write down a mint function which has two parameters, the address underscore 2 and an integer signed to 56 token ID. So it is taking two parameters from the calling function as an input, and it is going to mint that token for the particular address. So before that we need to check that a contract creator can only mint token. Okay, so means that only the contract creator, means the person who has created this contract or the address who created this contract can only mint the token, and nobody else address or the second address or third address can't mint this token in this particular situation. So we need to write down a require function for this to check. Okay, and the condition for this is to check that that given address should not be uninitialized, means the address which is came from the calling function, that is the address of the creator, should not be uninitialized. Address 0. Okay, so in Solidity, uninitializations means the code is for uninitialized address is 0x0, means there is no address present at this point. So whenever we have to check uninitialized address, that time we can use this address in bracket 0. So this is an initialized address. After that, we also need to check that token ID that we are going to generate will pass to token owner variable, and it should return the address of the token ID, and this address should be uninitialized. Okay, means that in this require function we have to check that the uninitialized address should not be assigned to any token ID, means it should be a 0. Okay, so token owner and its token ID we are checking that address that okay, let me check the code here. It is giving me an error here. So what is the problem? Okay, this is the problem here. So in this require statement, we are checking that the token ID which we are generating should not have any address linked to it. So that's why I am passing this token ID to this token owner mapping. So it will return me an address. So that address should not equal to some address. So it should always be an address 0, means it should be an initialized address. So that means that the token is not set to any address here. Okay, so that's why I am using this require statement here. And after that, we need to add more conditions here. But after this, we need to set this address to that token ID, and for that we need to write down this code, that is token owner that is a token ID, and that is to this address. So we are setting this address to this token ID to this token owner here. So it is setting this address to this event 256. After that, we need to push this token to the own tokens dynamic array. Okay, so for that we need to use this owned tokens address of the 2, then push this by using this push method, and we are pushing this token ID to that own tokens array list. So in this line we have just set up the
address to the token ID, and after that in this line we have pushed the token ID to this own token array list. After that we need to transfer this token by using transfer method. So we are writing this code, emit transfer, and now by using this method we are transferring that token to that address with that token ID. So it is coming from no address, means 0x0 address, to this 2 address with that token ID. Okay, so after this transfer function, this token which is minted by the address will be transferred to that particular address with that token ID. So this is it for this lecture. We will meet you in the next lecture. Thanks for watching. So hello everyone. So today we are going to add some more functions in our ERC721 smart contract. So this function will help us to get some more additional information, such as token ID of a particular owner, after that balances of some owners, and token list of particular addresses. So let's get started with the first function that we are going to write today, is that owner of a particular token ID. So for that we need to write down the function. So function owner of, and I need to pass the token ID here. Okay, so that is integer 56 token ID, and after that I need to declare this public view returns address, open your curly braces. So actually this function will return the address of that particular token ID. So actually here is some typo. Okay, so to get the address of the particular token ID, we need to pass this token ID to the token owner here, to this mapping. Okay, for that I need to write down token owner, and I need to pass this token ID here. I need to change also here that variable. Okay, so token ID. So this will give me the token address for that particular token ID. Okay, so now I need to store this address to the particular variable. So for that I am going to use address and a variable name. If I write down owner, okay, so I will store the address of that particular token ID in this owner, and after that I will return this owner variable to the calling function. Okay, so this is the code for this owner of function. Okay, but there is a problem here with the token ID returning address, because if the token ID does not return a proper address,
and it gives us an uninitialized address, that is 0x0, then it will give us an error, and this function will return a false results to us. So for to check this and to avoid this problem, we need to use require statement here, okay, which will check whether the owner's address is initialized or proper or not. Okay, so for that we can write this require statement here and the condition where we will check that owner's address should not be uninitialized address, okay, that is address 0. Okay, so remove this. So this is the owner of function that you can write and get the owner of particular token ID in this function. Okay, so next function is the balance of function. So balance of function will return the amount of tokens which is belonging to the particular owner. So for that we need to write down this function, which will be the same function as of this function. Okay, so but we are going to write down, so function balance of, and we are passing the address of owner. After that public view returns this will return event 256, the length of the tokens for the particular address. I need to open curly braces for this, and in this we need to write down return owned tokens, and here we need to pass the owner's address and length. So this will return us the length of the tokens for that particular owner. Okay, so how much tokens the particular address owns. Okay, so the balance of function will give us the balance for that particular address, how much token it is owning. So our next function is the tokens of function, which will returns the token list of a particular address. Okay, so for that we need to write down that function. So that function would be the same like this one. Okay, but in this function we are getting the length of the total tokens, means that if there is a for the particular address, if there are 5 tokens belong to that particular address, then it will give us the 5 number. Okay, but in the tokens of function it will give us the proper tokens list for that things. Okay, so for that we need to write down this function. So function, okay, and tokens of we need to pass here the address of an owner. It is returns the array of unsigned integer to 56. Okay, so this will give you a total number of token for that particular address. So list of tokens. So for that, return, we need to access this mapping on tokens. So this is an array from where we will get the tokens of particular address. So owned tokens, and we need to pass here the owner's address. So this will give us the tokens for that particular. Okay, so I need to open this curly braces here, sorry for that. Okay, so this is the function for this. So in the next lecture we are going to add new file for our gradient. So this is the just functions for the ERC721 token, but in the next lecture we are going to pass the values for this mint function and other functions from that file, and then we will get the result whatever we wanted in the next lecture. So for this lecture, this is it. We will meet in the next lecture. Thanks for watching.
Hi everyone. So today we are going to write down another smart contract called Ownable, so that we are going to use in our gradient SOL file that we are going to create after this Ownable smart contract. Okay, so let's get started to create a new file called ownable.sol. Okay, so we are going to use this file in a gradient file. So before that, what we are going to check in this file is that we are going to check that the owner of this contract can only mint the tokens, means that he can only mint the tokens. So for that we need to do some coding for this, and we need to write down some smart contract here. So for that, first of all, I need to explain you some new Solidity concept called a modifier. So that is we are going to use in this smart contract. So what is a modifier is actually, so let me write down some code, then you can understand that what is meant by a modifier and what is the use of that. So let me do some function here. So I can write a function. Suppose that function is add function, and it is a public one. Okay, and in this function we are checking that only owner of this contract, or the owner who has deployed this contract, can only do the addition. For that purpose we need to write this require statement, which will check that the message dot sender should be equal to owner. Okay, and if you want, we can here do the variable thing, that is address owner. Okay, and after that I will write code like uint c is equal to 5 plus 4. Okay, and now here you can see that I have this require function. Okay, and if there is a same function, okay, but it is a subtract, then
Okay, it is doing the subtraction here. So here you can see that we have this code same here and here in this functions. So we know that in every programming language we are told that if there is a function that is that you are writing every time in different functions or in a classes, that time you can use a generic function where you can write down this code in that function, and you can use that function whenever you want to call that particular piece of code, right? So here is also the same case here, that the required statement is present in both the function. Okay, so here is a spelling mistake, function. Okay, so it is an example, it is giving me a Solidity compiler errors, but this is just an example. That's why I'm not writing down some pragma or compiling statements here. Okay, so what is a modifier then? So this is the concept in a Solidity. Okay, so you can use the modifier and its name. If it is like only owner can call or something like that. Okay, and after that what you can do is that you can cut, copy or paste this code here, and after that you have to put underscore here, and you have to give this semicolon here. So how actually this code actually works, right? So here you will find that this is the modifier function, and here you will see that the code that you are going to use again and again, that we have written here, and this is the underscore and the semicolon. So whenever you run this program in a Solidity, so in the background what happened is that suppose this is the function where you want to use this thing, then this, okay, so you need to use this like public only owner can call. You have to use this here, and after that what happened is that this code in the background will call, okay, and that is placed instead of this underscore, it will be placed here. But this process is in the background, not on the foreground, right? So in the background this code actually works like this. So you can define one modifier class anywhere in the code. You put the whatever line amount of code in that modifier function, and you can call that modifier to that function like this. Okay, so in this enable contract we are going to use this modifier. I think and I hope that you are you get the idea of this modifier here. Okay, so let me delete all these things and start with our real code. So I need to write down this pragma Solidity, then our version, that is 0.4.23 that we are using here. Okay, after that I need to write down the contract, that is enable and I'm opening my curly braces, and in this contract, first of all, I will define one address variable for owner's address, owner, right? So this is giving me some errors. Okay, so as always, go to CRLF and click on this LF here. Okay, and after that I need to define one constructor which will be invoked when this contract is deployed on the test network or in a near real network. Okay, so constructor, I'm making it public, and in this constructor what I am going to do is that I am assigning this owner variable. Okay, I am assigning this owner variable the address of the message.sender. Okay, so owner is equal to message.sender. So as all of you know that the message.sender is the address who is actually deployed this contract. Okay, and we have already seen in the previous lecture that message is the global variable that you can access anywhere. Okay, in a smart contract. So I am getting the value of the deployed contract address through this message.sender, and I am assigning this address to this owner. So I have the address of the owner, right? After that I will be writing down the modifier that I am going to use in my gradient solidity file in the next lecture. So right now I am just defining it here. So only owner, right? And here I am giving the required condition, that is message dot sender is equal to owner, right? Here I am actually doing or checking that whoever may be the sender, he should always be the owner of this contract. If he is not an owner of this contract, then you can't call this gradient or mint function in the other smart contract. So this is the thing that I am checking here. Okay, so what is the use of this only owner and how we are going to apply in our smart contracts and in this project, we are going to see in the next lecture. So we will meet in the next lecture, and thanks for watching.
Hello everyone. So in the last lecture we have seen this ownable contract, and we have written down some code about the owner and the modifier that we are going to use in the next lecture that we have said in the last lecture. And in this lecture we are going to use this modifier, and we are going to create a new smart contract called a gradient token .solidity file. Okay, so it has the structure of the gradient. Okay, in that file you are going to write down whatever you may want the structure of the token. Okay, so this file actually decides what type of a token do you wanted for your ERC721 non-fungible token. Okay, so for that we need to write down the code for that. Before that I am going to create a solidity file in my contract folder. So go and click on this contracts and click on this new file, and after that I am going to say that my file is a radiant token .sol file. Okay, after that I need to write down some code here. So in this file what we are going to do is that in this file we are going to define as one smart contract in which we are defining the name and symbol for this token. After that, what is the structure for this token, and after that we are going to use the mint function, which is going to create a new token for us in this project. Okay, in the last lectures what we have seen that we have already created a mint function in the ERC721 token file. So this is the function. So in this function what we have seen is that we have passed the address of the owner and the token ID here, but this is just a function. We need to call this function to do its work. So from this file gradient token.sol, we are going to call this function, and then we will get a token from this. Okay, so let's get started with this Solidity compiler version first. So write down the first line, that is your pragma Solidity, and our version we are going to use is 0.4. Sorry, it's dollar, not a dollar, it's upper arrow character, and then 0.4.23. this is the version we are going to use. Okay, after that I need to import two file for this, because we are going to use their functionality in this smart contract. So for that I need to use import. So import, and in this import I am going to import first this file, that is ERC721 token SOL, and after that semicolon, and after that second is my import enable .sol. Okay, so here I am going to use this enable .solidity file also, because I need to check that only the owner of the contract deployer can mint the tokens. Nobody else will be able to, or should not be able to, mint the tokens. That's why I have defined this enable file previously in the last lectures, right? And in that file we have already checked that the owner should be there. Okay, whoever will be the deployed the contracts, only he will or she will able to mint the tokens, right? So we have already checked that condition in this file. Okay, and so this condition we are going to use in this contract also. That's why I imported those files here. Okay, and after that what I have to do is that I need to write down my contract here. Okay, so for that I am going to write down my contract. Okay, contract gradient token, and it is using these files. Okay, both these files, ERC721 token and enable Okay, so it is giving me an error, so let's click here on LF. Okay, so okay, let me check on this error, what is the issue with this. Okay, and let me come back on. Okay, so it is just my editor's error. I just need to save this file and then that error actually gone. Okay, so after that I need to use two variables. Okay, first is the name of the token, and after second is the name of the symbol of the token. So for that I am going to use string public constant name, and I am going to use the name like gradient token. Okay, and second variable is string public constant, and this is the symbol, and I'm going to say it's grad. Okay, so the symbols and the name. So if you are familiar with the ERC721 or ERC20 and any token system, you have to give the name for the token and the symbol for the token. So whatever may be the ERC standard you are going to use. Okay, but these two things you must have to define the name for the token and the symbol for the token. Okay, so let me see what is the error here. Okay, just I need to put this semicolon here. Okay, so I have defined these two strings. Okay, first is the name and second is the symbol here. Okay, and after that I need to give the structure for this. Okay, so for that what we want to have the gradient associated with every token. Okay, so we will use a circular gradients represented by two colors in this smart contracts. Means that our token will look like a circular thing, circular gradient. Okay, but it has a two color, one is an inner color and second is outer color. Okay, and instead of gradient you can use like any other structures, like you can use any structure like a different car, like kittens, dogs, anything that you want to use in this contract you can use. But for the tutorial purpose I am keeping it simple and I am going to use the circular gradient. Okay, which has two colors in it. Okay, so Solidity allows you to define new types of data types, right, in the form of struct. We have already see the definition of the struct and how we actually use that struct in the last lectures, right? So in this lecture also we are going to use the struct which will define the structure for this token. Okay, so for that I need to define this struct. Okay, which will store our gradient representation, right? Okay, so let's define this struct gradient, and in that I am going to define string for outer color and string for inner color, right? Okay, so now I have defined this struct here. Okay, so our gradient struct contains two string type fields, right? uh, uh, as we have seen in the last lecture, that struct have also other type of fields, okay, but in this smart contract I am going to use only a string type of the structure, okay. So now we are also going to use an array, okay, for this. So I think everybody knows about the array, okay, but let me explain about the little bit of about array. So there are two types of array structures we our developers used, right. First is your static array and second is your dynamic array. So the static array looks like this. For example, string, and it has a like this structure, okay, means that only 0 to 6 character you can save in this string, okay, but after that it can't store anything above 7 character, right. But if we don't know about the input string or the size of the string that we will get, then we can use this dynamic array like this. We just need to keep this blank here, okay, and this is called a dynamic array that we can use whenever we don't know about the length of an array, right. So in this smart contract also we are going to define a dynamic array, okay. So let's do that, okay. I am deleting this imaginary structure here, okay. So just let's define this, okay, gradient, okay. I am using this struct variable or the struct name for this array, right, because I need to store the tokens in this structures variable, that is a gradient, right. That's why I am going to use this. So gradient, it's dynamic array, sorry, I'm marking it public and making its variable that is gradients, okay. So what we have done is that we have used this struct variable, okay, or a struct thing here, structure thing, and we have created a dynamic array here, and we have created its variable here. So after that in the next lecture what we are going to do is that we are going to write down a mint function, okay, in this solidity contract, so that you will get idea how actually this minting is going to work with that ERC721 token contract, okay. So we will see that in the next lecture. Thanks for watching. Hello. So in the last lecture we have written down some code in this contract, okay, and in this lecture we are continuing this smart contract here, okay. So as I mentioned in the last lecture, that in this lecture I am going to show you the minting function that we are going to write down, okay. So actually whenever we want to create a new token, that time we need to use this mint function, okay. So let's get started with this mint function. So I am going to write down the code for this minting function first, and then I will explain the whole code line by line to you, okay. So just let me write down the code first. So function mint, okay, then string outer string inner, I'm making it public, and payable, and only owner can do the use of this function, only owner. Okay, so after that I need to write down the variable, that is a gradient. I'm going to use memory, gradient, after that gradient, okay, I need to pass the inner and outer values here, so outer, and inner, after that another variable I need to use, that is uint gradient id, push -1, and after that I need to call the mint function from ERC721 token. Okay, so here, okay, so here I am going to use this, sorry, message dot sender, and token ID is my gradient ID, that is gradient ID. Okay, sorry, use this variable here. Okay, so right now I have written this code here first. Now let me explain this code. Okay, so first of all I have write down the function here, then its name, and I am passing two strings here, the outer and inner values. Okay, and after that I am making this public and payable. So the payable keyword used whenever you the caller wants to send some ether along with the function, that time the payable keyword is used. Okay, so here whoever, maybe the owner or the caller of this function, needs to pay the gas to the Ethereum, so that's why they need to pay some ethers to call this function. That's why they will send the ethers with this function call. That's why I use this payable keyword here, and I have used this modifier only owner. Okay, from this ownable file, right? So only the owner of this contract can mint the tokens. Okay, no one else will be able to use this function or mint the tokens. Okay, so this is the restriction that I have put it up here. Okay, so after that what I have done is that first I define a memory gradient variable here. Okay, so memory gradient variable here, and in memory means that that lifespan of this variable will be limited by the execution scope. Okay, so in the Solidity there are three types of storing database. Okay, so first is the storage,
second is the memory, and third is the stack. So by default, like you integer and the string, always use this stack kind of data storing method. Okay, it's by default method in Solidity. Okay, after that after that there is a memory type, okay, that we have used here. This is the memory type. Okay, so this is the cheaper one. Actually, cheaper means that it don't require too much gas to store the variable value, right? And it will be erased between the function calls, right? And after that there is a third one that is called a storage type, and this is the most expensive one, you can say, because the data will be persisted between the contract calls also. That is why people or the developers need to aware of these things before writing or using these memory or storage functions, because it will cost you an gas to store the variables in your smart contract, right? So that's why I have used a memory here. Okay, and okay, so after that what I have done is that, so in our case we need this variable only for temporary time. That's why I used memory storage type. Okay, and I have passed the inner and outer values to this gradient structure. Okay, so these values will be passed here, and after that I have to define the gradient ID. Okay, and I am getting the new length of this gradient array, okay, by pushing this gradient variable here. Okay, and I am doing -1, so I will start from 0, or it will start from 0, and after that I am calling this mint function. Okay, so this mint function will do some things. Okay, so it will call this mint function. Okay, I am passing the message.sender, means the address of the owner. Okay, and gradient ID means the token ID here. Okay, so what will this method or this will do, that it will call this ERC721 token contract, and it will find that mint function here. Okay, and these two values, the message.sender and gradient's token ID, will be passed here. Okay, in this 2 and in this token ID event 256. Okay, and it will check that the recipient address is valid. Okay, here the recipient address should be valid, not a 0. Okay, otherwise it will throw an error. Okay, and after that it creates the token here. It will create that token and assign it to owner in these 2 lines, and after that it will fire this transfer method. Okay, and then assign that particular token to that particular owner by doing this transfer. Okay, so this is the function of mint. Okay, in the next lecture we will writing down some another function for getting the gradient info. So now add more one function, that is get gradient. Okay, so this get gradient method will give us the gradient data associated with the specific token. Okay, so write down that function, that is a function. Okay, get gradient. Okay, and in that I am passing the token ID, that is event. So that is my gradient ID here. So gradient ID, and I am making this function as a public, and this is not modifying the data, it's just giving me the view of the data. That's why I'm going to use this view. Okay, and this will returns inner and outer strings. Okay, so returns
So string outer and string inner. Okay, and I need to open the curly braces for this, and after that I need to use this struct here. Okay, and its variable, so I am going to use that struct name gradient, and I am going to use the memory for that, and the variable for that is grad. I am going to define, and now I need gradients array that is defined here. Okay, and I am passing to this array the gradient, a particular gradient ID. So gradients and underscore gradient ID. Okay, so I am getting some error, identifier but not got a memory. Okay, let me check with this error what is actually this is. Okay, so let me check this at my end, and then let me continue here. Oh sorry, actually I have written this code outside of the function, that's why it is giving me an error. So actually I forgotten here, I need to paste this code here. Okay, and let me clear this up, and after that I need to pass the outer and outer, that is, so I will get the values of that particular token ID from this array. Okay, and that I am storing in this grad. So I will get the whatever may be the inner and outer value from this grad variable. So use this grad variable here. So grad dot outer and inner, that is the same, grad dot inner. Okay, so this is the function for getting the gradient value. Okay, gradient data associated with the specific token owner. Okay, that we are going to call this get gradient method in our UI section whenever we start that UI section in the next upcoming chapters or in the next lectures. That time we are going to use this method for right now, thanks for watching. Hello everyone, so today we are going to see the new module, that is a testing module. Okay, so how we are going to write down the test cases for this smart contracts, and how we are going to test the contracts that we have written in the last lectures. Okay, so Truffle provides us the Chai and the Mocha test frameworks in the Truffle framework. Okay, so in this lecture we are going to see where we have to write down the test and how we are going to write down the test and what is the process for that. Okay, but before that we need to create one file, and I will going to explain what and how we are going to write down the test and what are the functions that the test supports. Okay, so first thing is that the testing things or testing framework like Mocha and Chai, which are present in Truffle, they supports .js files. Okay, so they supports only .js files, and those tests are written in this test folder. Okay, here we need to create test files. So I am going to create a test file that we are going to use for our gradient token testing. Okay, so let's click on this test folder and go and click on a new file. and give it a name. So I am giving a name gradient token.js, token test.js. Okay, so it's a JavaScript file that we are going to use for the testing things. But before going into the testing code and the testing thing, let me first explain that actually how we are going to write down the test in the truffle, and what is the structure that the Mocha or this truffle actually supports. Okay, so for that I need to first explain you some of the functions that we are going to write down in our project for the testing things, right? So first thing is that what are the functions that are supported by this truffle testing framework, right? So let me write down the functions and their purpose here. Okay, so we are going to use IT, that is it, and its purpose is to run a test and make an assertions. Okay, after that we are going to use describe, which groups its statements. So whenever you have many its statements in your test cases, okay, that time you can use, and you have to use this describe function. So it groups together all the it function. And third one is a before each. Okay, so it executes some of the general setup code. So execute some general needed or setup code, you can say. Okay, so these are the functions that we are going to use in this truffle testing framework. Okay, so it is used to run a test. So whenever you have to check some contract function, that time you have to use this it function and write down the testing code in that it function, and then it sorry, I think here is the ms dog, and after that it make an assertions on that. So we need to describe this it function in the test. After that, if there are too many it functions in your test, that time you have to use this describe function. So it just groups together all the it functions, and before each function is used when you have some code that need to be initialized or need to be set up before each test. That time you can use this before each function. Okay, so now I am going to show you some just basic example that how we are going to write down a test. Okay, that is not a real test. This is just an example that I am going to show you, so you will get an idea how we are going to write down the real test for this smart contract. So let me enter here. So here now I am going to write down example class. Okay, so if I mentioned a class, okay, class like a car, and in that I want to test a park function, okay, which returns me stopped, and another there is a drive function that I also wanted to test. and it returns me room. Okay, so now I wanted to this is my class and these are my functions, and I wanted to test these functions whether or not they are returning the same result that I wanted or that I mentioned here, or they are making some another result. Okay, so what in the testing, what we actually check is that the result that we wanted or that we have mentioned and the result which is generated by the code is the same or not. So that is the assertions that we need to make in the test, right? So this is just a class. Now I have to write down test cases for this. Okay, so for that I am going to use this describe function. So describe and in describe function I have to mention two parameters. Okay, first is the comment that will describe you okay, which thing is executed, and so it will just for the reporting part. Okay, so whatever you may want to add up here, you can add up. Okay, so for example I can add up like a car or car test, something like that. Okay, so if I put this like a car test, then I can say here like that. Okay, and after that I need to give the second parameter, and that is the arrow parameter that I am going to give here. Okay, so that is the syntax for this is like this. Okay, and after that I need to mention the test code in this. Okay, so as we have mentioned earlier that we always mention the testing code in it function. So I need to write down it function here. So it, and it also takes a two parameter. Okay, first is the comment parameter. You can put anything here. Okay, so I say like car park, or can I park. Okay, and after that also I need to put the arrow parameter here. Okay, and in that I need to mention the code. Okay, so for that I can assert here. Okay, so assert equal car.park, and I am checking with this value, that is stopped. Okay, so what is I am checking here is that I am checking that whether the code generated thing or the result is the same that I wanted in this lecture, or I wanted in this assert is the same or not, right? So if I run this code in a Mocha or in this truffle, okay, but we are not running this code right now. Okay, this is just an example. So I think if I run this code in Mocha or in truffle, so it will give me or it should return me this top stage, right? And if it is it gives me some other results, okay, in this parameter, and this thing is different, okay, then that test you can say it is a fail one. Okay, so it fails because the code generated thing or the result is different than what you are expected here, right? So also before this I need to call this class, because class is outside of this describe and it function. So I need to make a variable for this, that the initialization of the class, right? So new car. Okay, so this is just an example. It is giving me an error, something like that, but I am just showing you how we actually write the code for the tests, right? So it is not a real code. Okay, after that I also can write down the code for the same, that is for the room function. So I am just going to copy this and paste it here. Okay, and I'm checking that room. Okay, and okay, so this is the way by which, okay, let me change this also. I need to change this drive. So okay, so in this thing we always assert that whatever may be the result should be equal or not, and upon that our test is either pass or fails, right? So we have seen these two things in this file. Now I am going to show this before each function. Okay, so when to use this before each function. So whenever you have a code that need to be initialized, or that you need to run before each statement, okay, that you can put in that before each statement. Okay, so for that you can write the code like this. Okay, so before each I am passing this arrow parameter here, and in that I can say something like that, log dot e or something like that, and logs. Okay, so how actually this before each function runs, right? So whenever you run this file in the truffle, okay, so whenever you run the test one by one, so before each test, okay, this file or this log will be run before each test. Okay, like that this will run, okay, first, after that this will run, and again this will run, and after that this will run. So this is the flow of this before each statement. Okay, so in our example here you can see that we need always this initialization of the car, so that we can use here. Okay, so we can remove this and put this here, and we can remove this and put it here. So whenever you run this test, so what this before each do is that it always initialize this car class before each test case or each statement, you can say. Okay, so another thing that you have to think is that if you are going to run this code in a truffle, it will give you an error of this car variable here. Okay, because it is not defined in this function or in this describe, so it is not accessible by this car variable. Okay, because it is outside of the scope, right? So for that what we can use, that we can remove this constant. Okay, this is the constant. So when we use a constant variable, so whenever there is a no value change for a particular variable, that time we can use a constant. Okay, but if the value of the car it change for each iterations, okay, so that time you have to use a let keyword. So you can use let car keyword. So here each time the value of the car changes, and you can use that value by using this let variable car. Okay, so this is how actually we write down these functions here. Okay, so okay, sorry, here is the problem. Okay, so this is how we actually write down the test and things for this. Okay, so okay, so by this way we are going to test the code or the smart contracts using the test cases that we are going to write down in the next lecture. I should have to mention here that in the test cases we also going to see this functionality called async and await. Okay, so it syncs the things. Okay, its name is async. Okay, but it syncs the proper things, it syncs the proper code for your test cases and wait for the particular things to be happened, and after that it will run the next code. So this is also the things that we are going to see in our next lecture. So in the next lecture we are going to write down the real test cases for this gradient token. Okay, so we will meet in the next lecture. Thanks for watching. Hello everyone. So in the last lecture we have seen how we are going to write down the test in Solidity, and how is the structure of this test and what are the functions that we used in the test cases. Okay, so in this lecture what we are going to do is that we are going to write down the real test for our gradient token Solidity contract. So let me delete all this thing here. Okay, and before that I need to mention one file or the code that we need to test our assets function for the real gradient token Solidity. So that is the asset revert.js file that we need to create in this test folder. Okay, that is a Node.js library for the asset function that we need to mention here. So for that I need to create a new file here in the test function. So let me create first this assert revert.js. okay, it is the library, that's why you does not need to code anything or remember anything here. Okay, you have to just go to the internet and find the code for this file and just copy and paste that code here, because that is a Node.js library and that nothing has to do with our actual coding. It just supports the functionality of some promises and asset functions for our code. So go to the google.com and find the asset revert. Okay, so just find asset revert. Okay, truffle asset revert. Okay, Open Zeppelin library has very good mentioning of that asset revert.js. okay, so go to their website. Let me find it. So sorry, this is not here. So let me check here, where is the file that is we need. So I need to find that file in this. Okay, actually there are lots of files here, but this is not the file. It is a ready-made code that we are looking. Okay, let me do this. .js. Okay, I think this is the link. Yes, this is the link. Okay, so you can go here and you can see this asset revert.js. So just go here and copy this code and paste it in our asset revert.js. okay, so and save this. Okay, I'm not going to explain this library here because this is just a library and their documentation is given on this Open Zeppelin Solidity GitHub pages. Okay, so we are actually interested in our test cases, so we are going to write down those test cases. Okay, so go to our gradient token JS test.js, right? And in this file, first thing we need to import this asset revert.js. okay, because it's a library. So just write down import asset revert from. Okay, the syntax of import is here than the Solidity file because it's a JS file. So don't get confused between the syntax of Solidity import and the JS import, right? So in this asset revert.js and just give the semicolon here. Okay, and after that you need to give this, you need to mention the gradient token artifact, which is a JSON representation of your token interface. Okay, so this is the thing that allows you to interact with your contract from JavaScript code. Okay, so we need to write down the artifact so that our JavaScript code can interact with our Solidity code. So for that, the syntax is like this: constant gradient token and pass on your artifacts. So artifacts dot require gradient token okay, and just close this thing with the semicolon. And after that you need to write down your contract. So contract, then pass your commenting value that is going to help you to understand which test or which things is running and passed or failed, right? So this is anything that you want to mention here. Okay, so I am going to mention like gradient token. Okay, and after that I need to mention the accounts. Okay, so whenever you test the things, you need a testing accounts. Okay, so the testing accounts that we are going to use are the Ganash's testing accounts, and those accounts are always open, they are not locked, so they are unlocked. And we will get here the accounts, those we can use for our testing things. So in this lecture we are just writing down the code and explaining the things. In the next lecture we are going to see how we are going to test and run this test cases on actual Ganache test network. Okay, so just I have to mention the accounts here, and after that I have to give this arrow thing. After that, now this is a contract that we are testing, and now in this test now we have to use this it function that help us to assert our assumption or the result. So just write down it, and in that again your commenting code. So in the first test case, I am checking that the first account should be an owner, or it should make first account an owner, right? So this test cases actually we have checked with the ownable already, okay, but for the example purpose we are writing down these test cases, okay. So let me should make first account an owner, right? Sorry. And the second parameter is your arrow here, and in that I need to write down the code, okay. So here first I need to wait for the gradient token contract to be deployed, okay. The deployed script that we need to write in this migration file, but that we will see that in the next lecture. But in this test case we have to check that our gradient token contract should be deployed before it can check the results, right? So that is the first thing. So let me use this await function here. So it will await for gradient token for deployed. So it will check that is our gradient token is deployed or not, okay, and it will give us an instance, okay, for the deployment address. So instance, and that I'm going to save with this let, okay. So its value always changes, that's why I'm not going to use constant here. I'm going to use this let keyword, okay. So after that what I need to do is that I need to check the owner also. So I am going to use let owner, and it is also wait for instance of owner, the address that we will get from this deployment, okay. This address we need to check, and we are checking that it should be the first address and it should be the owner always, right? So use await and instance dot owner, and after that I am going to check the assertion by using assert dot equal. I am checking this owner variable, owner, and this accounts. This is not initialized account, or the sorry, not initialized, not, this is the first account. So here I am running this contract block here, okay, in the test, and that deploys our contract, and we wait for the contract to be deployed here, okay, and the request owner, which returns the owner's address, okay. So this will returns the owner address in this owner variable, and then we assert that owner's address is the same, okay. So this owner's address should be the same as of this account 0, means the first account, okay. So this is the test case that we have written for this. So sorry. And okay, just I forgot here that this should be an async, so it should be synchronized properly one after one. That's why we need to use this async thing also. So first this thing will be checked, or this thing will be run, and after that this, and after this. Okay, so this is the first test that we have written in this code, and after in the next lecture we are going to write down another test case, okay, for the mint. Okay, so we will see you in the next lecture. Okay, just I forget here the semicolon, okay, to complete this. So we will see the next test case in the next lecture. Thanks for watching this. Hello everyone. So in the last lecture we have write down this it function for the first test, okay, and in this lecture we are going to write down a second test, okay, and I am going to show you this describe function also. So in this test I am going to write down only one test, and second is the just it function, but it does not do anything. I am just showing you how we can group this it function, two it functions together using this describe function. So let me use this describe, and it also takes two parameters. First is the comment that we are going to test this mint function, and the same arrow thing, sorry, and in this we are going to write down two it functions. So let me write down the first it function here. So in this function actually I am checking that the token with the specified outer and inner colors, so whether or not the particular created token has the specified outer and inner color or not, okay, that is I am going to check in this. Okay, for that I need to write down it, and in that first creates a token, creates a token, or create a token with specified outer and inner colors, and the second parameter is the async function. That I am opening here it and writing down the code in that. So first we need to check this let instance thing. So always we need to check this, that the contract is always should be deployed before the testing. So you can copy this code and put down it here. And the second thing is that the main function can only be called by the owner. So I am using these two variables or these two lines of code from this it function. Okay, so after that I need to pass the inner and outer color to the main function. Okay, that is the fixed value that we are checking. So let's use await. It's okay, and await. So we have the instance of this gradient token which is deployed here. So use instance to call that main function. So instance dot mint, and in that pass on some values of color in hash, right? So use hash. So I am passing like 0ff00dd or hash ddff.
anything you wanted. Okay, you can also go to this google.com and you can find the hash values for colors also, and here you will find different colors and the websites that you can go and check and copy those things here. Okay, and let me save this into the variable that is token. And after that I need to use this method tokens of. So let me directly code that thing, the variable, and after that await. Okay, instance dot token of, and I am passing the owner address here, and after that let gradients is equal to await instance of get gradient method. Tokens at 0th position. Okay, I will explain this code. Okay, don't worry, just write me down this code before, and after that I asserting that. So here I am going to use this deep equal thing. Okay, so this is not different than this equal. Okay, but it just checks the child values also. So this is the deep one, so it checks child values also. So the first parameter is a gradient, because the result which will I get from the tokens from address 0 is in this variable. So I need to check what is actually I am getting from this. So gradients, and in here I need to check this child values, that is my hash ff00dd. so actually I have added 3f, so actually those are only 2, and second is your hash value dd ff. Okay, so this will check the things. Let me complete this and complete this also, and so we actually here use this describe function. So you can also write down some another it function here. Okay, so you can have that blank it function, or whatever you wanted to, like test this something, and then pass your value here, that is like this. Okay, so this is just this I am showing you how to test functions are write down or should be written in this describe function. So we are not going to write down the third test for a particular smart contract, so we are actually writing only these two test cases, and we are only checking these two test cases in this project. Okay, so actually this code actually do
this is a very actually simple test case, you can say. So it just in the first we test that we can mint a new token, okay, and then we expect that current account has now that token, and we are asserting it using that get gradient function, okay, that we have created before. So this is the just a simple test case that you can use to check the token with the specified inner and outer color. Okay, so in the next lecture we are going to run these test cases, and I will show you how to run the test cases in with the Ganache. So we will meet in the next lecture, and we will run these test cases, and we will see whether we have any problems or not. And if we have any problems in the code or something like that, we are going to check and repair that code, and we will see. So thanks for watching this lecture. Hello everyone. So in the last lecture we have written down our test cases here. This is the first contract and their cases, and then we have seen the describe function also and it function also. Okay, now in this lecture we are going to run this test cases, and we are going to compile this contract also. So before that we need to deploy this contract on a Ganache test network. So for that you need to start your Ganache. So I am opening my Ganache here. So it is opening right now. Okay, so Ganache have this 10 accounts with balance of 100 ether each. Okay, this is the just test software for testing purpose, and this is the mnemonic that you can use to get these same accounts for your testing. After that there is a blocks, transaction, and everything is here, and this is the RPC server and the port number that we will connect with this port to the Ganache. So go to our code, and if we take look at our code here, here you will find that what we have tested or what we have written in the first line is that we need to be our contract need to be deployed first, and then we will test the next code after that. So for the deployment purpose we need to write down a deploy file in which we need to script the deployment process, and those files are present in migrations folder. So for that you can go and just copy this initial migration file. So I am just going to copy this file and click on this migration and paste it here, and press F2 to rename this. So rename to deploy underscore contract. Okay, and in this, and we need to change this migrations to gradient token dot sol file, gradient token dot sol file. Then copy this gradient token here and change here to gradient tokens. Copy this and paste it here and save this file. Okay, so after that we need to connect with our Ganache here, and for that we need to open this truffle.js file, and in this file we need to put the script to connect with this Ganache or the local network. So this script you will find on the Truffle website. So we will go to this Truffle website. So Truffle development network. Find this term in the Google and go to the documentation on this truffle framework.com, and here you'll find the code for the development. So just copy the code from here to here. Don't copy this module.exports because it is already present in our file and it is auto generated. So just we need this code. So just check the port here, that our port is a 7545. So we need to change this port because here the port is 8545. Okay, that is a Geth port and we are not using the Geth, we are using Ganache. So that's why we are going to use 7545. Okay, check it again, 7545. So when we run this code on our truffle command prompt, then we will connect with this Ganache and we can test our code. Okay, so now our deployment script is ready, our truffle.js file and its script is ready. After that we need to go to the ERC20 token 721. Okay, and in this actually we not written down all the functions and we are not described all the functions in our code, or we are not used these two methods. That's why I am going to comment this, because I have just mentioned and explained those things here, but I have not used, or we have not used in our project. That's why I am going to comment this. Save this file, and after that go to our gradient token also. And here also in the previous lecture I have mentioned that we need to copy and paste up this asset river.js file from the internet, but we are not using this asset river.js for any testing purpose here. So that's why I am going to also comment this code here. Okay, I have just explained that if you are going to use this asset revert functionality, then you need to import this file from the internet or from Open Zeppelin GitHub pages. So we have not used this asset revert.js file in our code, that's why I have commented this line, and I am going to delete this file also. Okay, now everything is done. Now what we have to do is that now we have to go and compile the code. So just click on this blank space here and open a terminal here and run this command, truffle compile first. So this code will be get compiled. Okay, now here you can see my code is successfully compiled. Okay, and here you will see that after compilation you will get this build folder, and in that build folder all the contracts been converted to all the JSON interfaces, and that JSON interfaces we can use while testing or in the front end. Okay, so now for the testing purpose and to run this file, we need to run this command. Okay, just click here, truffle test. I think there is some problem I am getting. Okay, the error actually I am getting is about this asset statement. So I think this file is not saved properly. So let me save this again and rerun the command again, truffle test. Okay, now here you can see that my all the test. Okay, let me do this. Here you can see that I have passed all my three test cases here. Okay, so first should make the first account an owner, so this is also correct. And second, creates token with the specified outer and inner colors is also get passed. And third is just a test, so all the three tests are passing successfully. Okay,
Congratulations on completing this project. So in this project we have seen what are the ERC standard tokens and how to and when and why to use them at a particular and for particular applications, right? As a recap, in the first session what we have seen is that we have seen is the basics of a blockchain. Okay, I have also introduced that project concept in the first session. After that we have also seen the basics of the solidity, what is a web3.js, right? After that the what types of variables and the mappings and all that stuff. So we have shown that say in session 1, right? And in session 2 we gone into the deep of ERC20, that is a fungible token, and we have implemented the fixed supply token, means the fixed supply or the same token in the remix, and we have tested in the remix. And we have also seen the difference between the fungible and non-fungible token, that is ERC20 and ERC721. And we also seen the major difference between ERC20, 721 and 875 very boldly in session 2, right? And in session 3 what we have done is that we have seen when and where and when to use those ERC standards, like whenever you have to generate some token and you want to give some tokens to the people, so that time you can use the ERC20 token or ERC223 token, depends on what is your requirement. But for the security purpose you can use the ERC223, okay, in the fungible token things, okay. But if you are making some applications like dApps, like for the property or some real estate, some things you want to attach to the token, or in the blockchain you want to store something, that time you can use the ERC721 or ERC875 protocol. So those are the best protocol for non-fungibility things, right? After that we have also see that the ERC1155, that is the best and the new token standard that they just have released, right? So we have also seen what are the advantages and disadvantages of the 1155, and what it gives edge over the 875. So that is also the best part of this ERC new standards. And I also showed you that what are the GitHub pages of ERC, what is EIP, and all that stuff, right, in session 3. And in session 4 what we have done is that we implemented the ERC875 functionality in a remix, and we tested in the remix that thing. We also implemented the ERC7 ERC21 protocol in the our project, right? And we tested using truffle. We have used the truffle in this project. So this is the recap for our project. So if you have any questions, and if you want to get in touch with us, you can contact us on our portal. Thanks again for doing this course successfully. Best luck for your future.